zombie process. We also see the amount of CPU that your process is consuming, that is the row before the last row, and the amount of memory that it consumes. Your Fortigate CLI is probably your best friend when you're administrating your Fortigate. So, a new series dedicated to CLI tips. Let's start. The first CLI that we will look into today is the get system status. Now, it isn't a fancy command. It doesn't sniff any packets. It doesn't show the different sessions that are running on your Fortigate. It just shows you the information. What is your Fortigate up to? So what can we see? We can see the Fortigate version, we can see the build number, we can see the different security profiles, database dates. We can also see the serial number of your Fortigate. We can see if your Fortigate is working in a NAT mode, that is Network Address Translation Layer 3 operating mode, or maybe it is working in a transparent mode, which is a layer 2 mode. If you are using VDOMs, it will show you. If you are in an HA mode that is working in a cluster, either in a passive mode or in an active mode, it will also show you. Currently, as we can see, we are not participating in an HA cluster, so the HA mode is standalone. We can also see if we're using a hard disk or maybe we're using a flash disk. So the get system status will show you the most relevant information regarding your Fortigate. Another chapter in 2 minutes CLI, and in this part we will look at the execute log display. How can we show up the different logs categories in the command line? Coming up. Logs are critical to your network stability and your network security. Now, it's a good practice to keep logs for at least a week. You can look at the logs either through your Fortigate or through a Forti analyzer or even a syslog server. Now, in your logs, you have different categories, and we will look at them through the command line. So for that, we'll use the execute log filter category. Now, if you're not familiar with the different categories, just press enter, and there you will see the different categories. So let's just use category 1 for event logs. Now, after doing so, you will need to write down execute log display. And there we have it. Now, it shows up only the 10 last log events. If you want to watch the other 10, just press again and you will see the other 10 log events. Fortigate also shows you that you have 237 logs that are found and only 10 logs are returned. 6.4 is one of the latest releases of Fortinet, and they're doing a great job from release to release, adding new features. And up until now, there were dozens of videos all over describing the new features of 6.4. Well, I've decided to create one that will focus on the more friendly features of 6.4. So let's start. The first friendly feature, is the execute speed test that you can do on your WAN interface. To do so, you'll have to have the SD-WAN network monitor license. Once you have one, you can jump up to your WAN interface and execute a speed test. Now, when you do so, the results will be added to your estimated bandwidth, the estimated WAN bandwidth, but you will have to be connected to FortiGuard and to, I believe, Google's or AWS speedtest servers. The second friendly feature is a fantastic one. I've been always asked when dealing with security profiles, which feature is supported either in flow-based inspection mode or in proxy-based inspection mode. And it seems that you, up until 6.4, you had to remember which feature is supported and where. So from now, you can actually create a new security profile. And if you wish to see which feature or which capability is supported under the proxy inspection mode, the only thing that you need to do is to click on the proxy based, and there you will see that you can only use content disarm and reconstruction under the proxy based mode. The same goes to web filter. Just click on the proxy based and you will see the features that are supported only on a proxy based inspection mode. The next friendly feature is actually not a feature. It is a way of describing things much more clearly. So when you go to a network SD-WAN and you add up new interfaces to be part of the SD-WAN interface, and the next thing is to create an SLA, a performance SLA, where you configure the SLA server and the SLA target. The next thing is to go to SD-WAN rules. Now, in SD-WAN rules, at the end, you actually create your SD-WAN strategy. The SD-WAN strategy can be manual, best quality, maximize bandwidth, and lowest cost. I can tell you that every student asks me, what does it mean? What is best quality? What is maximized bandwidth? So finally, Fortinet actually describes each strategy and what it does. The next friendly feature is a cool feature, which is the IP address tooltip. Whenever you hover with your mouse over an IP address, it will show up more information on that IP address. So let's go to login report and application control, and let's see what happens when we hover towards that IP address. Well, we can see that the owner is Google. We can see their location, which is England. We can also see the latitude, longitude, and the running services. Let's go to another IP address, and that IP address also is owned by Google. Let's find an IP address which may not be owned by Google. All right, so we have an IP address that the owner is Amazon, and it seems as the local CDN here in Israel, Tel Aviv. Another friendly feature is the Add widget, which is now much more organized than it was before. You have dozens of widgets. Some of them are new. I believe that the IPsec and the SSL VPN widgets are new. And you have a bunch of Wi-Fi widgets that shows you the channel utilization of the access point, clients per access point, interfering access points, and so on. And the last friendly feature is the fact that you now don't have an IPv4 policy and an IPv6 policy. You only have a firewall policy. You can add up an IPv6 or an IPv4 address object to be added to the source and destination fields in your one policy. I'm using the CLI a lot. The following is my most frequent commands. I'm not going to show you granular commands that are used to debug VPNs or to change the severity of logs. I'm going to show you what I use in everyday scenario. So let's start. The following commands are not listed in a specific order, they're just my most frequent commands. So the very first command that I always use is the diagsys-stop. That helps me to see which processes are actually running on my Fortigate. That's a good indication when you're having issues with resources that a specific daemon, a specific process is using too much memory or consumes too much CPU resources. The second command is the diag sniffer packet. Now, the diag sniffer packet will actually let you packet capture the traffic on your Fortigate. You can do it in different verbosity levels. That's very similar to TCP dump. You can also do it using the graphical user interface. It has different parameters that you can enter in the command itself, but let's just use the diag sniffer packet any, that is sniff any packet on any interface. And doing so, we will actually see the different packets that are being sent by different sources. All right. Now, the third command is it's one of my best. Actually, there are two commands. The first one is the get system session list. And here we can see the different sessions that are happening on your Fortigate from different sources, either being netted or not. And the second one, if you want to be much more specific, is the diagsys session list. Now, this will list all these sessions, and it will give you the state of the session, either made dirty or dirty, which protocol is being used, what is the state of the protocol, the session serial, and so on. Is it using traffic shaping? Now, for that, we will actually use the filter option. So you will use the diagsys session filter. And from here, you can choose different filters. Let's just use the source filter, and you can enter the specific device, specific IP address that you want to see the sessions. All right, so let's just, currently my device is offline, so you won't see any sessions happening from the 10.0.5.7. The next command is the diag user device list. Now, this will list all the devices that are connected or that you see traffic that is coming from different interfaces. You can see either the MAC address, you can see the vendor such as Apple, and you can see the device detection algorithm, either using the MAC address or using other methods such as DHCP or ARP or any other method that Fortigate supports. You can also use it to see users that are using the proxy. So if you use the diag web stats, you will see the different sessions, but if you use the diag user device, then you will see the different proxy users that are actually using a proxy if you've enabled it in one of your interfaces. All right, another command is the show system interface. Now, if you press the question mark, you will see all the interfaces. You can also see specific information on specific port. So let's just get out of this one. All right, show system interface. Now let's use port 1, for example, and there you can see the port configuration. If you want to be much more specific, then you can use the diag hardware device info NIC, and then the port of choice. In our case, it's port 1. Here you will see the MAC address of that interface. You will see the number of packets that are being sent, the number of packets that are being dropped, the state of the interface, the state of the link, the size of the MTU. In most cases, it will be 1500 bytes, but there are specific cases that you will want to make it bigger. All right. The next thing is the get system ARP that is used to see who is actually connected. This is great to see devices that are connected to the different interfaces. And the last command that we will look at is the execute ping options, where you can actually adjust the ping command that will be sent towards different destinations in terms of size, in terms of interval between each ping, in terms of count, how many packets are to be sent. In terms of source, you can actually send from a specific interface to a specific destination. So you're not only limited to the WAN interface that you're using. You're a small business, very small. 6 employees, 6 computers, 1 switch, 1 access point, an ISP router, 1 subnet, and a network attached storage that serves as a file server. That's right, no domain controller servers, no clustering, everything is flat and simple. But you still want to protect your network assets. You still want to be able to connect to your file servers from remote, give permissions to the management to specific domains, and you decided to buy a firewall, a small firewall, not too fancy. So here are the 7 things you must do in order to start and work with your firewall. All right, so the following are the basic steps that you as a small business will need to do once you get your Fortigate or any other firewall in your business. Now, the very first thing, remember, once you configure your firewall, you're the administrator of that firewall. You're the super admin. So you will need to hardening your admin account. You can use two-factor authentication. You can also use an email-based mean to get a token in your email. I have done a video on that before, and you can just click the link above and go straight to it. Another thing is trusted host. You will need to configure either 1, 2, or 3 IP addresses that the admin can actually connect from to the management interface of your Fortigate. So configure your office address, configure your home address. Don't let anyone get into your Fortigate from outside. The second thing that you can do is to segment your network. Now, even if you have only 6 or 10 employees, and 3 of them are in the marketing department, and 4 of them are doing sales, create a new interface. You have lots of switch ports on your Fortigate, and even if don't, you can create virtual LANs. So let's create an interface. Let's just name our interface sales. The role of that interface is local area network. Just assign specific subnet to that interface. This is a private IP address. Use for management HTTPS and SSH. HTTPS to get to that interface through the GUI, and SSH is through the command line, and just configure a DHCP server. Now, you probably have only about 5 to 6 employees, so don't use the full pool. You can use, if in our case it's 10.0.9.2, so let's use it up until .10. Now, you can do many other things. We will not get into it right now, but this is the basics of just creating a new interface, and be sure to connect those employees through their computers to that specific switch on your FortiGate, either using a switch or directly. All right, now once you've built the interfaces, you can actually start to configure some rules. Let's just use basic rules for now. We head over to policy and objects, IPv4 policies, create new, and let's just create a sales policy. Now, we're not limiting no one in our sales department. So the incoming interface is sale, the outgoing interface is our WAN interface, the interface that is connected to our ISP router. As for source, currently we will use all, but we will create a firewall address object very soon, and we can actually use it in our firewall policies. In terms of service, we will allow any service, any protocol to go through this firewall policy. We will enable NAT. We will not use currently our security profiles. We will do it soon. And we will log just about every session, not only security events session. All right. So that's our sales policy. Let's create a new policy. Let's name it marketing. And incoming interface is our marketing. Outgoing is our WAN. Source all. Destination all. Service all. Let's just enable logging for all sessions. All right, the next thing to do is to actually create a virtual LAN for our access point. Now, there are times when you need to create another broadcast domain which is on top of physical ports. So if your FortiGate has 8 ports, you can actually create on top of each port VLANs, virtual LANs that you can connect to that switch, and from there to outsource employees or other employees. So let's just use the sales port to create another interface, which is our VLAN interface. Let's name it outsource 2, and we will use a tagging of 300. Let's also use it here. And the interface, as we said, is the sales interface. Now let's configure an IP address as we do in just about every subnet, every LAN that we have. So we'll use the 192.168.2.1/24, and we'll use administrative access, HTTPS and SSH, and we will actually list the full pool in our DHCP server. We will not limit it to only specific number of IP addresses. Okay, now once we have that VLAN on our sales interface, that's VLAN 300, we need to create a policy that will allow any traffic that is coming from that VLAN to get out to the internet. So we will again create a new policy. Let's name it outsource 2. The incoming interface is our VLAN, is outsource 2, and the outgoing is our WAN interface. Now, anyone can connect to that VLAN, anyone can go anywhere, but in terms of service, we will not allow any service out there. We will use HTTPS, HTTP, all right, and DNS. All right, now let's just apply that, and now we have a new policy that allows anyone that connects to it to get out to the internet only using HTTP, HTTPS, and DNS. All right, now let's create a firewall address object. Why do we need a firewall address object? Well, sometimes we have different computers on our subnet that we want to limit or to grant access to specific services, and that's a good way to create a policy that is more granular. So to create a firewall address object, we'll go to policy and objects, addresses. Now let's decide that our firewall address object will be for the marketing division. That's at the 10.0.5.0 subnet. And we know that we have a user that has the 10.0.5.3 IP address, and we want to limit it from sending pings, sending ICMP protocol pings. So how do we do that? We go to the policy and objects, addresses, create new address. Now let's name our computer limited ICMP. That's a nice name. Let's use the IP range, and let's use the 10.0.5.2 up to 10.0.5.2, or we said that it will be .3. And the interface is the marketing interface. Okay, we can also use static route configuration if we want to use it in a specific static route, but we don't need it for now. Let's just apply that. And now let's create a new policy. And in our new policy, we will name it no ICMP for that specific device. So the incoming interface is marketing, the outgoing is the WAN interface, and the source is the new limited ISP source that we have just created. Destination all, service ICMP. We want to limit it from sending ICMP ping. So we'll choose all ICMP and ping, and in the action we will choose deny. Okay, so now we have a policy that denies ICMP or denies pings from that specific users. Now for that policy to work, we need to actually move that policy before the marketing policy. So our firewall will look at that policy, will understand that that specific device, which belongs to the marketing division, doesn't have full access the same as the other user. It limits him from sending ICMP. Now the next thing you will need to do is to create a static route so that all packets from different interfaces will know where to go in order to get out to the internet. So to do so, you'll go to network static route, create new static route. Now I have already created one here. That's my static route. The destination is all zeros. That is, every packet that is destined anywhere and doesn't have a route in the routing table will go through that static route. You will need to choose the interface. In our case, that's the WAN interface, which is connected to our ISP router. We will not look at the administrative distance or the priority of that route, but know that you can actually prioritize different static routes on your Fortigate firewall. Alright, so we actually reached our final step, final configuration, which is applying security profiles to your policies. Now, you can find security profiles just beneath policy and objects, and you have different security profiles. Each security profile have its own knowledge base, and you can find dozens of videos in my channel that explains how to work with antivirus, web filter, DNS filter. The idea is that you actually create a security profile and then you apply it on your policy. So let's just open one policy, let's edit it, and here you can find the different security profiles. Once you enable it, it actually scans the traffic and looks for viruses, malware, spam, domains that are not permitted, and other things. Application control is probably one of the most used security profiles out there. Now, each application in the application database has its own unique ID. It can be TeamViewer, Netflix, Amazon apps, or any other application. Now, your application sensor actually uses the IPS engine that looks at the different protocols, looks at the different traffic, decodes the protocol, looks for patterns, and then when it knows that a specific application flows through the different interfaces, it tells so in the session list. So let's take a look at how the application unique ID shows up in the session table. so the very first thing that we need to do is to head over to Fortigate Labs, Threat Lookups, Application Control. Now here we can look at the different unique IDs that each application has. Let's look at TeamViewer. All right, we have different vulnerabilities, but we will look at the application category. And here we have TeamViewer, and let's just press it. And there it is. That's the unique ID of TeamViewer. The second app that we will look is Netflix. There we have Netflix, and Netflix has the unique ID of 18155. All right, so let's move to our Ubuntu device. And let's just enable TeamViewer. Oh, there it is. All right, and it is working. So let's move back to our FortiGate. Let's just use the DIEXIS session list. And we see that we have dozens of sessions. We cannot actually look at the different sessions, so we will use the grep command. And the very first app that we will look is the Netflix app, 18155. 18155. And there we have it. We have a session, that's the session ID. The serial is actually the session ID. And we have a session that actually the Netflix app actually uses. So that's the app ID. So let's get back to our Ubuntu. And let's look at the TeamViewer. It is working. And there we have it. That's the session ID, and that's the app, the TeamViewer app that actually initiated that session. Asymmetric encryption is being used just about everywhere. Let's look at the following scenario, and then we will dive in and understand how it actually works. So let's assume that Eve wants to send a message to Bob. She writes down the message, she encrypts it using its own symmetric key, and then when it is all encrypted, it is being sent to Bob. Now, Bob knows the key, it knows the symmetric key that Eve used. He uses it, and by that, he actually decrypts the message. Now, if you think about it, we actually achieved only one thing. We encrypted the message. But then again, we have other challenges. The first one, how can we deliver the key between Eve and Bob? Let's assume that Eve and Bob doesn't live close by. The second challenge is, how can we tell that the message wasn't modified? How can we tell that no one actually modified with the bits of the message itself? And the third challenge, how can we tell that the person who claims to be Eve is really Eve? For that, we have asymmetric encryption coming up. When Eve encrypted her message, she actually used asymmetric encryption, and the key that was used by the algorithm was known also to Bob. Let's just take a look at the terminal, and let's just make it bigger, and let's generate a random key. So we'll use for that OpenSSL rand, which is a command that allows you to generate pseudo-random numbers, integers. Let's use a key in hexadecimal, and let's use an 8-byte key, and that is the key. That is the key that could be used in asymmetric key encryption and that both parties should be aware of. So if we get back to Eve and Bob, Eve used this key with its algorithm. It could be either AES, it can be DES, it can be 3DES, any symmetric encryption algorithm. And Bob used the same key. So both parties has the same key. They both know that the algorithm is either AES or 3DES, and the message could be decrypted on the other side. On asymmetric encryption, Eve actually generates two key pairs. They may look similar, but they are actually different, mathematically related, but different. The first key is the private key. The private key is actually the secret key that Eve needs to keep in a secret place. The second key is the public key, and as the name suggests, it is public. Everyone can use that key. Now, when Bob gets the key, it can use it for asymmetric encryption and actually decrypt messages that were sent by Eve. It can also encrypt his own messages using the public key, and from there just send it back towards Eve, and Eve can decrypt it. So if we'll go back to OpenSSL, let's just write down OpenSSL, GNRSA. RSA is one of the algorithms of asymmetric encryption, and we'll use the 2048-bit key. And that's our private key. That's our private key. We can actually generate the public key from the private key that we have just generated. But that's the private key that Eve has actually generated. And as we said, it should be kept secret. And there we have it. Eve generates a private key and a public key and sends the public key again to Bob. Now Bob gets its public key, and from now on it can decrypt Eve's messages. Now think about it. The fact that only his public key can decrypt Eve's messages suggests that the message actually came from Eve. That's one way to authenticate the other side. Now, in fact, asymmetric encryption is not used to encrypt the session itself, the data, the payload that is being sent from Eve to Bob and vice versa, for many reasons. One of them is the size of the keys. So what actually is being done is that the private and the public keys are being used to encrypt the session keys, the symmetric encryption keys. They are much smaller in size, and they are being decrypted and encrypted much faster than asymmetric encryption keys. So Eve can actually generate a pseudo-random key that is a symmetric key, encrypt it using its own private key. Bob can get the encrypted message, open it with its own public key, and now he knows what is the symmetric key that Eve will use to encrypt the whole session. Auditing your firewall is a major task that you need to do from time to time. Now, there are companies that release tools that will allow you to audit your firewall, but here is the 10 best practices that you can start with. The following best practices are not in a specific order, so just use them as you wish. Now, another thing, I'm showing it on a Fortigate firewall, but you can also do it on a Checkpoint firewall, on the Palo Alto firewall, any next generation firewall. Quite obvious, but we do it on any device, any servers that we have on our organization. Be sure that your firmware is up to date. Always use the latest firmware. Usually the latest firmwares are much more secure. Your firewall vendor will always make sure that you have the latest patches on the latest firmware. So back up your configuration, look at the release path, and update your firmware. Encryption and high encryption is fundamental in your firewall. So be sure that you always use the strongest algorithms. Now, it's not always possible, but assuming that the other side also supports the strongest algorithms, just find out the appropriate CLI command on your firewall and enable it. So in a Fortigate firewall, it is config system global. Now it may change from firmware to firmware. Set crypto strong and just be sure to enable it. Always make sure that your administrator is connecting to your Fortigate through a trusted host. That is a trusted IP address as the IP address at its home or in the office. Now, you can do it using the graphical user interface. You can do it using the CLI. Let's do it using the CLI, config system admin. Let's edit the admin. And from here, set trusted host. And just write down the trusted IP address. If possible, on your WAN interface, your external facing interface, don't allow any administrative management. So let's just use the config system interface, edit port 1, which is my internet facing interface, and unset allow access. On your LAN interface administrative access, try always to use HTTPS and SSH, that is HTTPS to the graphical user interface and SSH to the command line. Now try to avoid ping and try to avoid other protocols unless needed. The following is probably one of the first audits that you need to do. Look for unused rules that were asked time ago and configured on your firewall. Look for them, and if they're not relevant anymore, just delete them. Now, a side note, document any rule that is asked. Document who asked the specific rule and the time that it was configured. Your administrator should always log into your Fortigate or any other firewall using HTTPS. So be sure that even if it tries to do it over HTTP, your firewall will redirect the request over HTTPS. So let's do it here. Config system global, set admin HTTPS redirect. Another setting that you should be aware of is the admin lockout and the admin lockout duration. Now, that should comply with your organization policy. Config system global. And now let's set the admin. You can set the admin lockout duration. The default is 60 seconds, but you can set it to 5 minutes or more. That should comply to your organization policy. Now, another setting is the threshold itself. That is, the lockout threshold is actually the number of failed attempts, when your admin tries to log into the system. The default is 3, and it is a best practice to keep it at 3. Logs should be part of your auditing. That is, when you audit a firewall, be sure that logs are there for at least 7 days. Now, look at the proper documentation of your firewall. Let's just do it here. Config log disk setting, set maximum age. Now, you can set it to 7 days. You can also set it to 30 days. It depends a lot where you save the logs, either on your hard disk or towards a syslog or any other device that has a proper storage. At last, let's look at some more best practices to hardening your firewall. One of them is when you have unused interfaces, disable them. Disable them. If you have interfaces that you want to disable different protocol, so just disable them using config system interface, edit the interface that you want to disable, and there you can unset DHCP relay services, you can unset PPTP client, ARP forwarding, and so on. Another thing that is quite common to any FortiGate out there, and that is something that I'm not familiar with other firewalls which have maybe yes or no the same functionality, is what is known as the maintainer account. The maintainer account is actually a backdoor to your FortiGate. If your admin has lost its password, then it allows you to actually boot into your FortiGate using what is known as the maintainer account, which is actually the serial number of your FortiGate with the maintainer user. So you can actually disable it. In most FortiGates, I believe that it is enabled by default. Set admin maintainer account disable. If you have not used them before, then start doing so. Auto scripts are extremely useful on your FortiGate. Now, I've done already a video on how to do it using the security fabric automation section. Now, most videos that deal with auto scripts deal with the possibility to back up your FortiGate, but you can do dozens of things. You can clear the ARP cache, you can flash your DNS cache, you can reboot your FortiGate, you can of course back up your FortiGate, or even restart your IPS engine. Alright, so let's start. Alright, so to configure an auto script, you will move to your command line, config system auto script. Now let's name our auto script, let's name it restart IPS. Alright. Once we do so, we actually created a new entry. And the next thing to do is to set the interval between these scripts. We will use 1 day, which is 86,400 seconds. You can of course change it, but let's assume that we want to make it once a day. Alright, so the next thing is the repeat, set repeat. How many times do you want it to happen? Do you want it to happen 1 time, 2 times, 3 times? Now, you can do it only 1 time if you have something that needs to be done on the same day, that is, just enter the integer 1, or if you want it to be infinite, that is, every day that task will be running, so you will set it to 0. The next thing is the start. Now you can actually start it manually or start it automatically. We will choose automatically. That is, it will start without any intervention from no one. Now, if you're doing a task that needs some output that is in terms of file size, you can actually determine the output size. Currently, we're only restarting the IPS engine, so we don't need that. The last thing is the script itself. Now, the script itself must start with double quotes. So let's set the script, double quotes, diag test application. Now, the application is IPS monitor, and the number is 99. All right, so let's configure another script, and this time we will clear the ARP table. So let's config system auto script. Let's just add it. Let's name it ARP-C for ARP clear. And let's set the interval. Let's set it again to once a day. But this time we want it to happen only once. And the script, again, reminding you that you have to begin and end it with double quotes. Execute clear system ARP table. All right, excellent. So let's just end it, and let's see the auto scripts that we have. So we have two scripts. The first one is the restart IPS, and the second one is clearing our ARP table. And again, you can use it for different tasks in different intervals, either to back up your Fortigate, to execute different commands. This is a fantastic tool. Automation is fundamental to every security appliance out there, and Fortigate is not different. Now, you can use automation in different ways. We will look at the Security Fabric automation stitches coming up. The idea behind automation stitches is quite simple. That is, it is very similar to if this then that. You choose a trigger and you choose the action that will follow. So let's create our first stitch. Let's name it reboot. The trigger is the machine that has just rebooted, and the action can be one thing or several things. We will choose two. The first one is CLI script. In the CLI script, you can actually write down any script. Let's just write down the most basic one, which is get system status. And the second thing that we want to do is to add up an email, so the output will be sent to the administrator email. Let's just write down the subject: machine has just rebooted. All right, so that's our first stitch. Now you can create stitches with schedules. So for example, you can create a backup stitch. Here we will schedule an event, which will be the backup. It will happen weekly in 12 o'clock and on Sunday when no one works. Now the action itself will be a CLI script, and the CLI script will be the execute backup config USB. Let's name it backup. We can also add up the password for that backup. Now, the idea is that you actually can do a bunch of things using the automation stitches that will help you to offload different tasks as an administrator. So you've got your new Fortigate. How do you configure it? Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you've got your new Fortigate and you're new to Fortigate firewalls. What do you need to do? You have probably connected your Fortigate using a network cable to your computer and configured it. Fortigate appliances comes with at least port 1, one of the ports, which is usually port 1, that is already configured with the IP address of 192.168.199. You need to configure your PC subnet to be on that same subnet, get to the IP address of the interface, of the port 1 interface, and from there you're actually starting to configure your Fortigate. Now you can configure a Fortigate using the graphical user interface, which has many features. It even has a feature visibility feature in the system settings so that you can disable or enable new features which are not available over here. Now you can configure your Fortigate using the graphical user interface, and you can configure it using the command line. Fortigate experts use the command line almost all of the time. We will look at the command line, but we will make our way using the graphical user interface. To get to the command line, you need to click here. It is actually a JavaScript app that runs on top the admin web app. Probably the first thing that you want to do is to write down get system status so you can see your Fortigate serial number, which ASICs, which accelerated hardware does it support. Are you using a hard disk or a flash drive? The current security profile database, and so on. Now, we went into the interfaces. You probably have one interface that you're connected to, which will be the management interface. Now you need to connect one of your WAN interface to your ISP, either through a modem router, or you can use your Fortigate as the router itself. Each interface has a physical switchboard that you can connect to different subnets in your network. Now let's just edit one interface. Let's see what's inside. You can name your interface according to the subnet in your local area network. Let's assume that we have a management subnet. All right, now you can define it a specific role. It can be a WAN, a DMZ, an undefined role, or a WAN. So let's use the LAN. So now we know that we have a management LAN connected to port 8 on our Fortigate. Now, the addressing mode can be manual, it can be DHCP. Let's use the manual option, and let's configure it to be 192.168.2.1/24, since we're using a 24 subnet. Now, this address is the gateway interface address. So any computer that will connect to one of to port 8 will get an IP address in that subnet, that is the 192.168.2.0 subnet, but its gateway address will be 2.1. Now we will also open the DHCP server, so anyone that is connected, there's a pool of IP address that it will grab. We'll look at DHCP server very soon. Before that, we need to configure administrative access. Which protocol will support administrative access? We'll just use HTTPS and HTTP. For now, we can also use SSH. We can also configure it to support pings from host in that subnet or from a Forti manager, but we will not do it right now. LLDP is a protocol that enables discovery between devices in the network. It doesn't really matter. You can disable or keep it for now. Now we have a DHCP server. As I said, any client that connects to that port will receive one of the IP addresses from the pool. You don't have to use all the pool. You can use only 20 IP addresses. You can keep the DNS server the same as configured here, or you can specify your own DNS server. Let's just specify Google's DNS server. You can control the list time, and if you click on the advanced, if you have a DHCP server that is part of your domain, which is not your Fortigate or your Fortigate interface, you can configure its IP address here, and then whenever a packet arrives on that interface, it will head over to the DHCP server. But for now, we're using the gateway interface as the DHCP server. You can configure an NTP server. You can configure, and this option is for more advanced users, DHCP scopes or options. And you can assign different IPs to different devices based on their MAC address. Another option is device detection. Device detections allows your Fortigate to detect which device and which operating system devices on the networks belongs to. This is one of the things that you should keep enabled. Don't bother with the explicit web proxy. You can enable a captive portal, so if you have outsourced employees and you wish to jump a landing page with user credentials, you can also do that, but we will skip it for now. So this is the basic configuration of the interface. Okay. So now we have a management interface. We have another interface, which is the WAN interface that you connect it. You connect it to your ISP router. We will call it WAN1. The role is WAN. We can use DHCP, and if we want to make it more reliable, we will use a static IP address. So my gateway interface is 10.0.3.75, and my router is actually 10.0.3.1. I've enabled HTTP and HTTPS, and as you can see, you don't have a DHCP server whenever the role of your interface is WAN. That is one of the best practices when using an interface as a WAN interface. Okay, so we have a management interface, we have a WAN interface. Now we want to make our managers that are connected to that port, which is port 8, to get out to the internet. So the next thing to do is to configure a policy. Now we will configure a very basic policy, which is a full access policy. Let's name it. Let's name it managers 1. And the incoming interface is management. That's the LAN interface of our managers. The outgoing interface is WAN1. That is the interface that is connected to our ISP router. That is the interface that takes them outside of the LAN towards the internet. Now, when it comes to source, for this video, let's make it very generic. Anyone can go. Anyone. We can configure user groups and different users. We can also configure sets of parameters that control the different users. But for now, as for source, anyone can get out. As for destination, they can go just about anywhere. We can also create specific objects that will allow them to go to specific places, but for now they can go just about anywhere. As for scheduling, we're not limiting them to specific hours or days. So as for scheduling, again, they can get out to the internet any time of the day. As for service, we can deny them from getting out in specific services such as FTP, but for now, for our specific policy, we will let them use just about any service. Now, the action is accept. We can also create a policy that will deny specific services or specific users from getting out or from doing specific things. For now, the action is accept. Inspection mode is another topic that we will look into. That is the inspection that is done to our networks when we're using security profiles such as antivirus or IPS. For now, we will keep it at flow-based mode. Now, we will use NAT. NAT is Network Address Translation. That is our private IP address, which can be 192.168.2.6, will be translated to your Fortigate or to your ISP public internet address. Now, we will not use security profiles. You know what? Let's use antivirus. Let's use the default profile, the default antivirus profile. We will use certificate inspection. When we use certificate inspection, your Fortigate checks the different fields that are coming from server certificates to see if they're valid, if it doesn't have any mismatches, and so on. The last thing is to use our logging options. We can log only security events, but we will log all sessions. So later on, we can look at the login report and see what our users or what our host did. Okay. So we have a managers one policy. We have two interfaces. The WAN1, which connects us to the outside, and the management interface, which managers in our company can connect to and get their IP addresses. That was the second step. Now the third step is to configure a static route. A static route is actually, for our usage, will be a default route. That is, I've already configured one, so let's just look at it. If you want to create new, you just create new. So default route actually tells your Fortigate that whenever he sees a packet, any packet that is destined to any place which doesn't have a route at the routing table, it will route it towards the WAN interface. And the WAN interface address is a 10.0.3.1. Remember, my ISP router has that address. Now you can use specific parameters as distance. You can use priority. It just tells me that I already have that static route, which I do. And once we have a static route, a policy, and interfaces that are configured correctly, we can now connect our host to the management interface, and those hosts can now get onto the internet. Let's just move to the CLI, and let's see how do we configure interfaces using the CLI. So for the sake of our purpose, let's configure port 7. So using the CLI, we will use the config system interface. Now let's edit port 7 as we said. Let's set its IP to 192.168.4.1 with a subnet of 24. Let's set the management protocols to HTTP and HTTPS. And what else? We can use many more. If you will look at the, let's end it. Now I want to show you something. When you config system interface, let's just get out here. Config system interface, and if we look at port 1, for example, we can use the show full config, and as you can see, there are dozens of features of configurations that you can add. For our sake, we have only enabled the IP address on that interface, and let's look at it. Let's just refresh our page. Port 7, and there it is. Now we can also configure the DHCP server and so on. We have not done so on our CLI. The last thing I want to show you, once you get into your Fortigate, you're actually the Fortigate administrators. Now you have two types of administrators on, actually you have more than two types, but the two most common types is a super admin, which is you. You have privileges to just about anything. You can read and write, and you can create another type of administrator, which is the professional admin, where you can actually enable it, different read and write privileges on the different places on your Fortigate. If you will head over to the CLI and use the config system admin, and you can edit the admin name. I have two admins. I have one which is the super admin, and the second one which is offer test, which is my second admin. So now let's look at the different configurations that you can add to your admin. Again, lots of configuration. That's not the only place where you can configure different things. You can also configure it on a globally, which is the config system global. But one of the things that I wanted to show you is that you can strengthen your admin account by using a trusted host. So you can also look at it here. sorry, here, you can configure a trusted host, that is a trusted IP address that only your admin can get from. So you can configure the IP address on your office at your work, and you can configure another trusted host, which is the IP address at your home. Only from those two IP addresses your admin can get into the Fortigate. You can also configure two-factor authentication, which is also a very common security procedure. You can use Forti token, and you can also use your email as a two-factor authentication. Let's just show you how to do so. Let's clear that out. So we can use the config system admin set. No, let's edit the profile before and set two-factor email, set email to, and let's set it to one of my Gmail accounts. Let's end it, and now if we'll go back to our admin profile, let's view it again, and you can see that you can now use an email-based two-factor authentication. When you configure a captive portal to one of your LAN interfaces, you can change and customize the look and feel of it. Coming up. So we have our LAN interface, which is connected to my Ubuntu device. So let's just open up the interface itself. And in network security mode, let's just choose captive portal, and let's choose a group that it is associated with it. Now you can choose your guest group, your outsourced employee group, just about any group you choose. All right, now when we head to our device, so let's enter Firefox, and that's what we get. We get the Fortinet logo, and the background is gray. Now we want to change it, so let's see how we do it. Let's just get back to our Fortigate. Now to do so, you need to go to System Replacement Messages. Now you have two views, the simple view and the extended view. We'll use this simple view, authentication, login page, edit. Here you will see the image itself and the HTML part. Now we will not get into the different texts that are in the login page. You can change it, but let's see how we change the image from Fortinet to FortiTip. All right, so to do so, we'll head over to Manage Images. Let's create new image. Let's name it FortiTip. And let's upload the image that we have already prepared. You need to have an image which is less than 24 kilobytes. All right, so that's the image. That's the name of the image. Let's name it FortiTip 1, since I already have a FortiTip image. All right, so here is FortiTip 1 and FortiTip. Now let's get back to our login page. Let's edit. Let's just scroll the HTML page, and let's find the logo part. Here's the logo part. Currently it is with a background, a gray background, so let's change it to all Fs, that is white in hexadecimal values. And let's just change the image to FortiTip 1. There we have it. Now let's just save it. And now we have a new login page, a new HTML page with our new image. So let's get back to our Ubuntu device. So let's start Firefox again. And there it is, the new logo, Forti logo. And again, you can change the background as I did. You can change the different text that is within the login page. You can do many things with the login page. There are times when you need to back up your configuration and send it via email to another compliant Fortigate. Now, there is one thing that you need to add up to your backup configuration file. Coming up. So there's our use case. We have another Fortigate and we want to send it our primary Fortigate configuration. Now, the other Fortigate must be compliant, but we will not get into it. So let's look at the configuration file. That's the configuration file. Let's just open it. And there it is. Now, we don't want no one to tamper with our configuration file, to get into the file itself and change things. How do we do it? We make a checksum. We make a hash value of the configuration file and add up the hash value to our mail. So to do so, I'm using a Mac terminal, but you can use PowerShell. You can use just about any tool with the hash commands available. So in my case, it is SHA-SUM-A. Now, we need to choose the type of hash function. I'm using 256, but you can also use 1. In our case, it doesn't really matter. Now, let's just drag the file to our terminal, and there we have it. That's the hash value. That's the hash value of our configuration file. So the next thing to do is to copy it, open our email, and just be sure to add up the hash value of our configuration file. Now, the other side that gets the configuration file itself just grabs the file, makes the same operation, which is SHA-256 sum and the file path. It should get the same hash value. If it doesn't get the same hash value, then someone tampered with that file. There are different ways that you can prioritize your cloud apps over the other apps. One way is to use a traffic shaping policy. Here's how. The following scenario is quite typical for many businesses. Now, if you're using more than one WAN interface, you can use static route, create different static route to each WAN interface and prioritize different internet services. You can also prioritize the interfaces. You can even use SD-WAN rules and performance SLA. Now, we will look at a case where we have only one WAN interface, and we will do it using the traffic shaping policy. So the very first thing that you will need to do is to move over to your policy and make sure that application control is on. The second thing you'll do is to move to security profile, application signatures, and there we will create an application group for the cloud applications that we used most often. So let's just name it cloud apps. And from here we can actually use the category, which can be cloud IT, or we can actually select our applications. So let's use the AWS, which we used often. Let's add up Salesforce. All right. And let's add up Office 365. There we have it. Now, let's just save our application group. We can see that we have a new application group that includes all of our cloud apps that our workers use most often. The third thing that you will need to do is to create a traffic shaping policy. Now, if you move to traffic shaping policy under policy and objects, you will see that you have two main traffic shapers. One is the high priority and the second one is the low priority. Both are in the shared IP shaper. So let's move to traffic shaping policy. Let's create a new traffic shaping policy. Let's just name our traffic shaping policy Cloud Apps. The source can be all, destination all, service all, in application. Now here is the place where we actually use our application group. So just look for the cloud apps that we have just created. That's our application group. And here in the shaper, we will actually apply, let's just add up the when interface. And here we will apply the high priority shaper. We will apply it in both shared shaper and reverse shaper, so that we'll have also the downlink and the uplink with high priority. Okay, so we have a policy, we have a traffic shaping policy for cloud apps. So let's create another traffic shaping policy for any other apps. All right, again, source all, destination all, service all. Now you can choose the applications, but you don't have to. And here in the traffic shaping place, let's just use the low priority, both in the shared shaper and in the reverse shaper. And now we actually have two traffic shaping policy. If you enable application control on your policy, your application control sensor will actually notice whenever you use Salesforce or other cloud apps, and your traffic shaping policy will actually prioritize it over the other. Your Fortigate firewall is a session-aware firewall. It has its own session table, which can be seen using the get system session list. And there are cases when you need to tear down a specific session or the entire sessions that are on your Fortigate. How do you do it? Coming up. Your Fortigate is a session-aware firewall. It holds information on its session table and keeps looking at its session table every time a packet goes out through a different interface or gets into another interface. Your session table actually holds much more than the session itself. It holds the routes, that is, whenever your Fortigate does a route lookup, it saves the information in the session table. Now let's look at our session, get system session list. And we can see that we have dozens of sessions, some of them to the same destination. I currently have a Ubuntu device which is at the 10.0.5.4, and let's assume that I need to clear out all session. So the command for that is diaxis session clear. Don't do that. Don't do that. It's quite dangerous to clear out all sessions that are happening on your Fortigate. Instead, we will use the filter option. Now you can filter out different session either by source interface, destination interface, source, and even protocol, which is quite interesting. Now we will use the source. So let's use the source, which is the 10.0.5.4. And the next thing to do just after that is the diaxis session clear. Once you do so, just press the enter, and specific sessions, the sessions that you have filtered, will be terminated. Your Fortigate uses its memory for the different processes, either IPS, antivirus, or general functionality. Now, when it reaches your memory threshold, it gets into what is known as a conserve mode. How do you control it, and how do you decide which operations takes place when you enter conserve mode? Coming up. Getting into a conserve mode is not a desirable thing. Now, there are actually 3 thresholds that you can actually configure by yourself, and those thresholds determine when you enter a conserve mode, when you exit from a conserve mode, and when the sessions are being dropped as you're entering an extreme threshold. So let's take a look at it. Let's just stop our DAG system and let's config system global. And in config system global, you can actually set the different thresholds. Now, the extreme threshold is actually the threshold or the percentage of total memory when your Fortigate starts to drop a session. You can also set the green thresholds, which is the thresholds where your Fortigate exits from the conserve mode. And there's the red threshold, that is the thresholds when your Fortigate enters conserve mode. Now, when your Fortigate enters conserve mode, something happens. The first one, your Fortigate doesn't accept any configuration changes. The second thing, it doesn't execute any quarantines. Now, there are other things that you can configure as sessions on your IPS engines and antivirus. So let's just get out of the different thresholds. Config IPS global. Set fail open. Now you can decide either to enable fail open or disable. If you enable IPS fail open, packets will still flow, will still go through the different interfaces, but with no IPS inspection. If you choose to disable it, the packets that require IPS inspection will be dropped. Now, if you want to check if you're in the conserve mode or not, you can just use the DAG hardware sysinfo conserve. If you do so, you can see that you're currently not in a conserve mode. If you were in conserve mode, you would see the on instead of the off. And you can also see your total RAM and the memory that is being used. You can also see that the threshold for the red extreme mode is actually 95% of total RAM. You will enter conserve mode at 88% of total memory, and you will exit from conserve mode when you get down the threshold of 82%. How do you control data consumption and bandwidth when everyone is at home? Coming up. To take control over data in COVID-19 times, we can use the traffic shaping policy in our Fortigate. So let's move to policy and objects, traffic shaper, create new shaper. Now we can use a shared shaper or we can use pair IP shaper. So let's use pair IP shaper. Let's name it COVID-19 streamer. So we'll know that it is for our streamer device. Now the maximum bandwidth, we will limit it to 30 megabits. And let's save our shaper. The second thing to do is traffic shaping policy. Let's move to traffic shaping policy, name our policy COVID-19. Now the source, we will need to create an address object for our streamer, so let's just do it. Let's streamer 1, since I already have one, 10.4.10.0.4.9/32. Okay, so we have our streamer device as our source. Destination is all. Now we can use specific applications such as Netflix and so on, but we do not want to limit our streamer device only to streaming applications. We want to limit the traffic as all. So we will not use the application or the URL category, but we will use in outgoing interface the WAN interface, and now we'll use the per IP shaper. Select your traffic shaper that you have just configured, and that's about it. Crypto mining malware or cryptojacking is a form of a malware that actually uses your own resources to mine cryptocurrencies. Now, the attack vectors, the way that the crypto miners gets into your organization can be either from botnets, it can be from malwares, it can be from JavaScripts that runs on your browsers. Now, as we've seen in the last several years, it can run on your routers, it can run on your PCs, on your Android smartphones, or on your servers. How do you protect your organization from crypto mining malwares? Coming up. Crypto mining software comes in many forms and can actually get into your resources from different locations. So how do you block them? Well, there's no one recipe. You will need to apply different security profiles. The first thing to do is to apply the antivirus security profiles in your policy. Why? Because Fortinet has actually included different signatures for crypto mining software. So if you're using either the normal database or the extreme database, just apply them to your policy. The second thing is to block different crypto botnets, and there are dozens of crypto botnets out there, so be sure to block botnets on your botnet package. The third thing to do is to block different applications that are related to cryptocurrency. How do you know which applications to block? Well, you can head over to the Fortigate labs and just look for cryptocurrency. There you will find different applications that actually tries to mine different cryptocurrencies. So the thing to do is to open your application control, and in the application override, just find the different signatures and block them. The other thing, as we said, there are different JavaScripts that run on your browser, and you will also need to block them using your IPS signature. Which signature is that? So again, move to your Fortigate labs, look for the different cryptocurrencies signatures, but if you want to be just a little bit more precise, look for javascript.cryptocurrency. And there you will find different generic JavaScripts that can run on your browser, and you need to block them. So just copy this one and block it on your IPS engine. On the following scenario, I will use the author microcontroller after connecting to it through the pwned SSID, and the authenticate, send deauthenticate, and deassociate frame, stores, and access point. Now, do it on your own risk. Do it only on equipment that you're allowed to do so, probably your own equipment. This demo is for educational purposes only. Alright, so to connect to the author page, we will head to the pwned SSID. Just type 192.168.4.1, and here we have several sections. The first one is the scan section, where the author actually scans the air for either access point or stations. Now we will select the access point, our access point that my TV, my other devices are connected to. Just select it and move over to the attacks section. Now there are several attacks. We will use the auth attack, and let's start the attack. But before we do it, let's just open up Wireshark and let's capture the air so we can see what is actually happening. So let's start the attack. And let's move back to our Wireshark, and as you can see, we have tons of the associate and the authenticate frames that are actually being sent. So let's stop the attack itself, and let's select the, let's just open the frame itself. Let's open the frame itself. Let's look for the associate frame, and we can see that it is being sent to the broadcast domains. So every station that will try to connect to our Wi-Fi access point or wireless router will actually get a de-authenticate frame and a de-associate if it is already connected to. When you want to get around your system admin, you can use the decoy technique in Nmap to scan the subnet that you're connected to, or the gateway that you're connected to. So we have our Ubuntu device, which is connected to the 10.0.4.1 subnet, and its IP address, let's just check it out. Let's use the ifconfig. The IP address of our Ubuntu device is the 10.0.4.8. So let's use the decoy technique and let's see how that looks in Wireshark. Alright, so the first thing to do is to open Wireshark. Let's capture traffic. And now let's move back to our Ubuntu device. Alright, and for that we will need root privileges, so we'll use the sudo. Let's use the full SYN scan, which is SS, and the target is our gateway, which is the 10.0.4.1. I remind you that's the gateway that our Ubuntu device is connected to. And the other thing to do is to use the decoy technique with the hyphen uppercase D. And let's presume that we are coming from the 10.0.7.33. All right. Now we get our results. We can see that we have HTTPS open. Now let's look at Wireshark. Let's close our capture and let's use the IP ADDR equal 10.0.7. Let me just take a look. .33. And there it is. Although our IP address was 10.0.4.8, that was the Ubuntu address, we used the decoy technique in Nmap to pretend to be the 10.0.7.33 and get information on our gateway. Now let's use the same one to get information on our WAN interface. And now let's use the 32. Let's just open Wireshark again. And here we have it. We can see that our gateway is actually quite open in terms of ports. Just about any port is open here. So that's definitely a vulnerability issue. But let's just open up Wireshark and let's stop our capture, and this time it is 32. So there we have it. Our Ubuntu device is trying to connect, is actually connecting to our WAN port. And to the right, we can see that our client is actually sending a SYN packet without sending back the acknowledgement. So let's create a system interface and a DHCP server using the command line. The following is part of the basic firewall training. We will set up an interface and a DHCP server. Let's do it on port 4. We will do it using the command line. So let's just use the config system interface. Alright, let's edit port 4. Let's just make it port 4. Let's set the IP to 10.0.7.1/24, and let's set the allow access, the management protocol access to ping, HTTP, HTTPS. We can also set the weight for that interface. Let's just give it a weight of 250. We can set different settings for that interface, but we will end with that. That will be our local area network interface for our finance department. Now, the second thing that we can do is to actually configure a DHCP server on that interface. So config system DHCP server. Let's edit that server. Let's create an entry, a new entry, and let's set the default gateway for that DHCP server to the 10.0.7.1, and let's also set the interface. We're creating that on the port 4 interface. Now let's configure the IP range, the pool of IP addresses that it will list for the clients that connect through that interface, and for that we will use the config IP range, and let's also use edit 1, and let's set the start IP at the 10.0.7.2, and let's set the end IP to 10.0.7.11. All right, next, and let's set the net mask to 255.255.255.0, that's /24, and let's set the DNS service to default. All right, now let's end it, and let's just refresh our page. Remember port 4. Let's refresh it, and there it is. And here we can see that we have our LAN at port 4. That's our finance LAN. That's the IP of the LAN gateway. That's the administrative access. And here's our DHCP server that starts with the 10.0.7.2 up to 10.07.11. And the DNS server is the same as the system DNS. 2 minutes CLI commands, and this time the diag sniffer coming up. Diag sniffer packet is one of my favorite commands. Why? Because it actually allows you to packet capture the traffic, sniff the traffic just as TCP dump or Wireshark does. So the syntax goes like that: diag sniffer packet, and then you need to include the interface. So we will do any, but you can choose port 1 or port 2. After that, you actually filter the traffic. You can filter it using the source destination protocol. We'll use the host, so we'll use the host 10.0.3.1, which is my gateway. Next comes the verbosity, that is the amount of data that you want to include. I will choose 4. And we can also add up the count, that is the packet count. So let's add up 10 packets. And if you want a timestamp, you can add the A letter. So let's start. And there we have it. Now you can play around with the different filters and the different verbosity levels. Do that. If you want a packet capture, not using the diag sniffer, but using the graphical user interface, you can do it in network, packet capture, and in packet capture you will find that you can choose the interface and use the different filters. We have already learned how we can list system processes and show their output on the command line. Now on this video we will look at how we can kill different processes that consumes too much memory or too much CPU power, and how we can list the highest demanding processes on our Fortigate. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you're using a high-level encryption in your VPN, you're using IPS to scan different patterns and anomalies, you're using antivirus, and you keep logging of just about anything. Well, all of that consumes lots and lots of CPU resources and memory. Let's take a look at the diag system command. Let's make an interval of 20 with 10 processes. Alright, now using the M character, you just need to type the M character. We can sort out the processes that consumes the highest memory, and in our case it is the DNS proxy. If we press the P character, that P is for CPU, we will see the different processes that consume the highest CPU resources, and in our case it is HTTPS daemon. Now the next step is to kill the process that causes you lots of issues. That is the last step before you reboot your Fortigate. Let's do a Control C. To kill a process, you use the diag sys kill. Now you enter what is called a signal. That is a term that comes from Linux and Unix, which is actually a polite way to ask your system to stop the process, and it can be a more aggressive way to tell your system, it depends on the number, to tell your system to kill the process. Now we can use different signal numbers. We will use 15, which is an aggressive way to tell your system kill that process, and we will list the process ID. Now the process ID, as we know, is the second column. So let's use the DNS proxy process, which is 94. Alright, now we have just killed that process. And here we can see that the DNS proxy process has actually been terminated. We saw that we can list processes, sort them out, and even terminate them whenever they demand too much resources. On our last part of knowing your processes, we will see how we can, in one CLI command, see the top most CPU demanding processes. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the features that we saw using the diag systop command is that we can list the most demanding processes, either CPU and memory, using the M and the P character when it is pressed. Now, there is another command, which is the get system performance top, which lists only the most demanding CPU processes. Let's see it in action. So we use the get sys, sorry for that, get sys performance top. Now you will see the most demanding processes, the most CPU demanding processes at the second most right column. That's the CPU column. The most right column is, as we know, the memory column. Now you will see different processes such as the IPS engine or the antivirus scanner, the new CLI, or even the SSHD, the SSH daemon. Now, whenever a process is too demanding in terms of CPU, you may need to kill that process, and we saw how to do it using the diag sys kill with a signal level and the process ID. The following video is dedicated to beginners who are just starting to administrate their Fortigate. This is a free 15 minutes masterclass, so let's start. So here we have the Fortigate administrator page. You can configure the different settings either by using the graphical user interface or by using the command line. We will mix between the two. I can tell you that using the command line, you will have access to much more advanced settings. Now, as for methodology, we will start with the administrator account. We will move into creating new interfaces, creating a static route, creating a policy that will match the traffic and will choose either to deny the traffic or to allow it. Then we will move to our security profiles. We will see how we can configure the antivirus, the web filter, application control, and so on. And from there, we will move into different settings that will make configuration much more strict into our purposes. So let's start. All right, so the very first thing to remember is that you're the administrator of that Fortigate. You have lots of responsibilities, starting from backing up the configuration and creating policies, interfaces, different settings, different authentication rules for your users. Now, if you will go over to System Administrator, the very first thing that you will need to do is to harden, make your account much more strict by using either a Forti token and trusted host. So you can actually configure specific IP addresses that you will log only from there. You can do it either using the graphical user interface or by moving into the command line. Here we will use the config system admin, and let's just edit the relevant profile, which is admin. Now here we can set different configurations to our admin profile. If we'll use the show full config, we will see the full configuration, either setting up trusted host or even setting up a two-factor authentication by using an email account. That is possible only on the command line. Alright, so we have our admin account. So now let's move over to network interfaces. And this is the topology that we need to configure. This is a very basic SMB topology. You have your LAN, which is connected to one interface on your Fortigate, and you have your DMZ where your server sits, which is connected to another interface, and you have your ISP router, which is connected to your WAN interface on your Fortigate, which is this WAN interface. So let's start by configuring the LAN interface and the DMZ interface. So choose your interface of choice, edit. Now name your interface. I will name it LAN, and choose its role. Different roles means different settings, but our role currently is LAN. We will configure the IP address of the gateway itself, that is 10.0.4.1/24. Another thing that we need to configure is the administrative access. We will use HTTPS to connect to that interface. We will also allow ping, and we need a service, a DHCP service that will run on our interface, so that hosts that will connect to our interface can ask for IP addresses, and we will apply that using the pool, which currently is up to 254. We will set it to only 50 IP addresses. You can head over to the more advanced DHCP server and assign scopes, assign specific IPs to match your host's MAC address, but we will not do so. Device detection allows your Fortigate to actually detect the type of devices that runs on your network. That is either an Android, a Windows PC, a Mac computer, and so on. It does so by looking at its MAC address, user agent, TCP fingerprint, and other methods. You can also enable captive portal on your interface. We will not do so. So that's it for our LAN interface. And now let's configure our DMZ interface. So let's edit it, name it DMZ. Now the role will be DMZ, and once you do so, you will see that you don't have a DHCP server on that interface, since as a best practice, do not allow DHCP service on your DMZ. So let's configure its IP address, 10.0.5.1/24. We will only use HTTPS as our administrative access, and that's it. Now we have two interfaces. One is dedicated to our LAN, and the other one is dedicated to our DMZ. Our WAN interface, let's just edit and name it WAN, so it will be easier when we configure our policy later on. Alright, so now we have our interfaces set up, and the next thing to do is to manually configure a route entry that will allow all packets to flow towards the gateway interface, that is our WAN interface, and from there to the internet. So we'll move to network, static route. Let's configure a new default route. Our gateway interface sits on the WAN interface, and its IP address is the 10.0.3.1. We can determine the priority of our static route and its distance using the following configuration, but we will not get into it. You can see I have dozens of videos that are dedicated to the different routing attributes of your Fortigate. Okay. So now we have one static route which actually tells different packets that if you wish to go to just about any destination that doesn't have its own routing entry in the routing table, move to the gateway at the 10.0.3.1 using the WAN interface. And now let's move and see our new entry, our new route entry that we have just configured. We will do so using the command line, although you can do so also using the graphical user interface. So get router info, routing table all. And there you see you have a new static route that actually points to the default route via the 10.0.3.1 IP address. All right, so we have our interfaces, we have a static route, and the next thing to do is actually to create the policy itself, the policy that will allow packets to flow from interface to interface by matching the traffic and seeing if it is denied or allowed. So to create a policy, we will move over to policy and objects, IPv4 policy, and create new. The first policy that we wish to create is a policy that will allow everyone in our LAN to get out to the internet using any service at any time. So let's just name our policy full access. The incoming interface is our LAN interface. The outgoing interface is our WAN interface. The source, we will not limit users, so we will just allow anyone to get out. Of course, if you need more granular control over your policy, you will create firewall address objects and you will define which one can get out and which one cannot. You can also create user groups and users. Destination, all. We are not limiting the traffic to a specific place. Anyone can get out to anywhere. Scheduling, always. Service, again, we can limit it to specific protocols, but we will keep it to all. Now, the action is accept. The other thing to note is the inspection mode, which we will look at when we create security profiles. We want our traffic to be netted. That is, our traffic currently happens on our private IP addresses, but when we go out to the public internet, we need to translate our IP addresses to the public front interface of our Fortigate. So that's what we will do. And we can configure the different security profiles. We will do it very soon. Now, in terms of logging, we don't want only security events to be logged. We want all sessions to be logged. So we will enable all sessions. Okay. So now we have our first policy, which is the full access policy. All right, so now let's create our second policy for the DMZ. And from the DMZ point of view, let's just allow traffic that comes from the internet towards the DMZ. For our purpose, let's just make it from anyone, but in your environment, just configure it based on your needs, security policy, events, and so on. Destination, all. We can, of course, configure a specific, let's just configure an address for our server. Let's assume that we have a web server that anyone can access using HTTP and HTTPS. So let's name it web server. We will use the 10.0.5.4/32. So we will so it will point out exclusively to that web server. Now the service can only be HTTP and HTTPS. We will use the different security profiles and we will log all sessions. Okay, so we have a second policy that is towards our DMZ, but now the traffic comes from outside towards a specific web server, and we have only allowed the HTTP and HTTP service. Now, once you finish up with your different policies, you will need to apply the different security profiles. For that, you will move over to security profiles, choose The one that suits your security needs, you will probably choose antivirus, web filter, maybe application control if you want to control applications that your users are using. And once you create a security profile and name it, you can enable it in your policy by going to the policy page and select which profile is needed. All right, now the last thing to do is to move to your system settings and choose the appropriate settings that will make you feel good while you administrate your Fortigate, either in terms of how much time do you want your idle timeout to be, how do you want to customize the look and feel of your Fortigate, and do you want to use any other email service other than the FortiGuard email service. So you can do all that. Now, we have actually looked at the basics of putting up your Fortigate in a typical scenario. If you want to learn more, please subscribe to my channel. I regularly upload 2 to 3 videos every week. If you're using one of Fortigate's latest firmware, then you will find out that the DLP, the data leak prevention, is not there anymore, at least not as a graphical user interface. Now, parts of it went to the web filter. You can actually use the file filter and block different types of files. But credit card and social security numbers, blocking or logging, can only be done using the command line. So let's take a look at how we configure a credit card sensor using the command line. Coming up. Credit card sensor matches numbers from credit cards. Those can be from MasterCard, Visa, American Express, and so on. Now, it can be used with files or with messages, that is, email messages. So let's configure our first credit card sensor, and let's start by config DLP sensor. Let's just edit, let's create an entry and config filter, and our first filter will be number 1. All right, so let's, you know what, let's skip the name of the filter. Let's set the type to message. We can also use files, but we are actually using now messages. And let's set the protocol. Now, since we're aiming at email protocols, those will be SMTP, POP3, and IMAP. All right. Now let's set the filter by credit card. You can also use social security number, or you can actually use regular expression if you're looking for specific patterns in the text itself, but we are using a credit card sensor. Let's just, now let's use next, let's end it, and let's set DLP log to enable. And that's it. That's how you create a basic credit card sensor. Now, there are other options that you can choose from, such as sensitivity and so on. So I urge you, look at the CLI reference and configure it the way you want. Let's look at some specific DNS settings that will make a change in your network. Coming up. You can configure your system DNS settings under the network DNS, where you can specify your DNS server's IP address. You can even set it up to work over TLS, which is a topic that I covered before. But let's look at the command line, and let's look at 2 configurations that are important. So let's config system DNS. Now here you can set up the primary DNS server or the secondary DNS server. Let's just set the primary to be Google's DNS server. And two configurations that are important are the cache time to live and the cache size. So let's set the set DNS cache limit, that is the amount of records that can be saved on your cache. By default it is 5,000, but you can set it up to a much higher number. That depends on your needs, but I have found that 5,000 records are quite enough. The other configuration that you need to look for is the set DNS time to live. Now the time to live is the amount of time that the DNS record is saved in your cache. That is the DNS response that you've got back. Now it is being saved on your cache. It actually serves you faster since it comes from the cache. It is much faster. It doesn't need to go all the way to an authoritative server. The default is 1800 seconds, which is 30 seconds. The maximum is about 86,000 seconds, which is 1 day. Now 30 minutes, as we said, is the default, but let's set it up to 1 hour, 3,600 seconds, and let's end it. And now let's just refresh our page, and there we have that our primary DNS server is the Google's DNS server. The secondary is actually Fortigate servers. Now one thing to note, if you for any reason need to clear your DNS cache, you can do it quickly using the diag test application DNS proxy. Now look at, once you press the enter button, you will see that you have different options. So just use number 1 and you will clear your DNS cache. If you create a VLAN on a physical interface, then you will notice that the VLAN actually inherits the physical interface MAC address. Let's do it and let's see it in action. So we have an interface, that's the finance interface at the 10.0.7.1, and let's create a new interface, a VLAN. Let's just give it a VLAN ID of 100. Let's name it finance outsource. Now the interface that it will sit on is the finance interface. Let's give it a unique IP address, its own broadcast domain at the 10.0.8.1/24, and enable the DHCP server. All right. Now, when we do so, we can actually see that our MAC address on the finance interface is this MAC address, which ends at BE. Now, if we look at the VLAN interface, let's just edit this one. That's the same MAC address. It's not so frequent, but there are times when you need a unique MAC address for your VLAN interface. You do it using the enhanced MAC VLAN. Coming up. Alright, so to configure an enhanced MAC VLAN, your VLAN has to have a unique ID. That is unique even if the different VLANs are on different VDOMs. Now you can implement it on a multi-VDOM environment, on a single VDOM. So before that, I've already deleted the finance out VLAN, and let's just take a look again at the MAC address. That's our MAC address, 6DBE at the end. So let's configure a new VLAN. For that, we'll use the config system interface. Let's name our new VLAN. Let's name it finance out. All right. And now let's set the type. If you use your tab key. You can actually move between different interfaces, the same as you would do on the graphical user interface. But here you will also have the eMac VLAN, the enhanced Mac VLAN. So let's just press enter. Now let's set the VLAN ID to something that is unique. Let's just use 120. Let's set the VDOM to the root VDOM. And now let's set the physical interface, which is actually, that's port 3. All right. Now let's just refresh our page. Let's move to interfaces, refresh them. And let's look at the finance interface. That's the finance interface. So the finance interface starts with 000C29 and our enhanced Mac VLAN interface, let's see, starts with 06. So the MAC address, although it seems similar, is actually different. So you have your LAN set up, your WAN interface set up, you have your static route and your policy. Now it's time to fine-tune your security profiles. Coming up. The following is not a recipe or a cookbook, it's all about fine-tuning tips for your security profiles. So let's start with the antivirus. Now you can configure your antivirus settings using the command line. Let's just get out of what is already on the screen. Config antivirus settings. And from here you can choose, let's just show the full config. You can choose the different databases that you wish to work with. So set default database and you can move between normal, extended and extreme. Be sure to also set the grayware to enable. Grayware are actually apps that are not by definition viruses or malwares, but these are apps that can harm and decrease your performance, such as adwares. The second thing is web filter, starting from 6.2 or 6.23. You can now block different file types. So you can block zip files, you can block PDF files, you can block Excel files, you can block them on different protocols. So be sure to do so. Another thing about web filtering is that you have proxy options. Be sure to enable proxy inspection mode on your policy. On DNS filter, you can block different botnets, but the thing about DNS filter is that you're actually blocking a domain. You're not blocking a URL. So you cannot block a subset of a domain, which is a URL, but you can block the full IP address or the full domain. So this one will work much faster on your Fortigate than web filtering. So be sure to be aware of that. In application control, you can actually block, override, enable different applications based on their categories. You can also block a category and override a specific application that belongs to that category. You can do it here, application and filter override. You can, and it is a best practice to block quick as Google's new protocol, since it actually influences your Fortigate performance and capabilities. Moving on to intrusion prevention, be sure to use IPS, create different and customized signatures if you need, but the most important thing to do is to configure your signatures based on the filtering options. If you're targeting clients, be sure to use the client filter, if you're targeting servers, if you're targeting different severity levels or different protocols, be sure to customize your IPS signatures based on the topology on your organization. Now, this is only the tip of the iceberg. There are lots of other configurations that you can do, such as config antivirus heuristic. You can use your web filtering with deep SSL inspection to log just about any keywords that your employees are looking for. You can use application control to enforce protocols on specific ports, and so on and so on. You can create customized signatures for specific events or specific anomalies that you're looking for. You can create a denial of service policy that is based on different anomalies, but be sure that it will be productive for your purposes. Firewall rules are basically the bread and butter of every firewall out there. It doesn't really matter if your firewall is a next generation firewall. Whenever you head out to the internet and you're using a firewall, then you're obliged to firewall rules. What are firewall rules and how are they made? Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. A firewall rule is nothing more than a set of criteria that your traffic needs to match. Whenever an IP session happens in your network, a set of rules are being matched against that traffic. If your firewall doesn't find a match at the first rule, then it goes to the next rule. Rules are handled from top to bottom. Now let's look at how a policy rule is being configured and what objects are used to create that match. In every rule, there's always the implicit deny rule that sits beneath every other rules. That is, if your firewall doesn't find any match in the traffic, then the traffic goes to the implicit deny rule and it is being dropped. So when we start to configure our firewall rule, we have, as we said, an implicit deny rule at the bottom. And from there, we start to configure our different criteria that will be matched against your traffic. Now we start with the name of the rule itself. As for naming conventions, don't use too many characters. Don't use spaces between words. Try to use underscores. The second thing is the incoming interface. What is the incoming interface? Well, that's the interface that your local area network is connected to, your DMZ is connected to, whatever interface that the traffic is coming from. The second criteria is the outgoing interface. So that usually in a full access rule, full access policy, that is your WAN interface when you configure your rule to allow traffic from the LAN towards the WAN and the internet. But it can also be another segment of your enterprise, another LAN. It can be the DMZ. The incoming interface is known as the ingress interface. The outgoing interface is known as the egress interface. So we have two interfaces, the incoming interface, the outgoing interface, and from there we move to the source. What is the source that makes the traffic? Well, that can be your clients. That can be just about any source, that is any IP address, or you can use what is known as firewall objects as specific IP addresses within your local area network. It can also be a user or a user group that is saved on your firewall internal database or a remote authentication server such as LDAP or a Radius server. Another criteria is the destination. What is the destination that your traffic is heading towards? It can be any destination, that is any IP address out there. It can be a specific IP that you can configure, or it can be a domain, or maybe an internet service, an Amazon service. So be sure to be granular. Don't just use any or all. Be specific. If you're configuring a full access policy that will allow anyone to get out towards the internet, then it will probably be all. If you're configuring specific destination, then be sure that to configure them ahead and use them in your rule. The next thing is scheduling. Do you want your policy to work out 24/7? Or do you want it to work on specific hours, specific days, reoccurring days? So you will probably have cases where you will be asked to open a firewall rule for a specific appliances in your local area network. It could be a backup device, it could be a network attached storage. Be sure to know what times are those appliances need that firewall rule. The next thing is service. Service, that is, which protocols are being used in your firewall rule. Are you using only HTTP, HTTPS, and DNS, that is port 80, port 443, port 53, or are you allowing your employees to get out to just about anywhere using any protocol out there, including FTP, SSH, and so on? So again, be careful with the service usage rights. And the last thing is the action. Are you denying or are you allowing traffic based on that match? Now, this was actually only the part one of your policy or rule creation. The next thing, once you have a match, is to go through security profiles. That is going through antivirus, application control, IPS, and so on. The other thing that you will have to take care is, are you using network address translation? Are you logging all sessions or only security events? If you look at my channel, you will find dozens of videos related to security profiles and other features of your firewall. So please check out, subscribe, and see you soon. One of the most basic security measures that we all do, especially now, is to block specific countries. That is, using a geolocation and block those specific countries. Now, most of us just create an address object, a firewall address object that is of type geographic, and then apply it to a deny policy. But that's not enough. To make your policy bulletproof, you will need to apply a local in policy. Coming up. When you create a security policy on your Fortigate, you actually control the traffic to and from your Fortigate. That is traffic that comes from the ingress interface to the egress interface and vice versa. Now, your FortiGate actually has another type of policies, which are the local in policies. Those policies actually restrict or enable user access to the internal traffic, that is the management traffic. How do you see the local in policies? You can head over to System, Feature Visibility, and here in Feature Visibility, let's look for the local in policy. Apply that. Once you do so, move again to the policies and objects, local in policy, and there you will see the type of protocols that are allowed for administration, for routing, for central management, and more. Now remember, if you create a firewall address object, then you're actually denying it only on the security policy level. You need to deny access also on the local in policy. So let's start by creating an address object. Let's create the policies, and then let's create the local in policy. The local in policy can only be configured through the command line. All right, so let's just head over to policy and objects, addresses. Now we can do it over the command line also. Config firewall address. Now let's add it and let's name the country that we wish to block. For the sake of demonstration, let's just use Iran. Now the type of address is geographic, so we need to set the type. You can scroll between the different types. Now geography is the type, so we will choose geography. And the next thing to do is to set the country. Now you need to set the first two letters. Now each country has its own characters. Now you probably don't know which are which, so just type a question mark and you will see the different countries and their first letters. So let's just look for Iran, Iraq, Iran, so IR is the initials. All right, so let's set the country to IR and let's end it. Now once we do so, again we can go to the addresses, and here we will find Iran. That's the firewall address object that we have just created. All right, so now let's move to our policy and let's create a new policy. Let's name our policy block country. The incoming interface is our marketing interface. The outgoing is our WAN. So we will block it using two policies. One is for the inbound traffic and the second is for the outbound traffic. The source is all, that is everyone in the marketing local area network, and the destination is the firewall address object that we have just created, that is all service and all time. So scheduling is always, and we will deny. So that's a deny policy. So we have done that on the internal LAN interface. Now let's do it from the WAN side. Okay. Let's name block country in. So our WAN interface would be used as the incoming. Our marketing interface is the outgoing. Source Iran and destination all. Service all, and again deny. So we have two security policies, one for the inbound and the second is for the outbound traffic. All right, and so now we need to create a local in policy that will deny access from a source address, which is Iran. All right, so to do so, we will need the command line. Let's just clear the page. Config firewall local in policy. Let's edit number 1. Let's set the interface. Currently my WAN1 is at port 1, so we will use port 1. Let's set the source address to Iran. Let's just look for Iran. There it is. That's the source address. We're trying to protect traffic that is coming from Iran. Let's set the destination address. Let's do it all. Let's do it all. And let's set service. Currently, we will also use, just 1 second. Let's set the service to all. All right. And let's set the schedule to always. And that's it. All right, so we have created a local in policy that will protect our internal traffic. And now let's just look at that again. Let's see what we have here. All right, so that's all for now. Now, if you're using VIP, if you're using virtual IP, you will need to match those to the policies, since VIP actually takes precedence over the IPv4 policy. That's all for now. Please subscribe and press the bell notification so you won't miss any. The following scenario is as follows. You have your local LAN users, you have your access point that is broadcasting its signal in the air, and you have an outsourced employee that starts to work at your organization, and you want to create a guest user. How do you do it? Coming up. Creating a guest access involves several steps. Now remember, a guest access is mostly an account that has a limited time period. So let's start with a user group. Let's create a new group. Let's name it guests. And the type will be guest. Now from here it's quite self-explanatory. The user ID of the guest will be its email. Now you can use an auto-generated password that your Fortigate will generate, but let's use specify, and when we will create a new user account you will see where to enter it. Now you can add up sponsor, you can add up company, and the period, let's add 24-hour period. So our account period will be 1 day. Now the next thing to do is guest management, where we create our user account. Remember, our user ID is the user email address. Now let's add up the password. Let's add the email itself. The company will be Forti, and let's just make sure that the expiration time is 1 day. The other thing that you need to do is to create an administrator that will handle the guest account. Let's name it admin guest, and let's add up its password, a simple password. Now the profile will be professional, and just choose the restrict admin to guest account provisioning only, and the guest group is the guest that we have just created. Now if we log out, let's just enter again as our admin guest. Let's see what the admin guest sees when he enters your Fortigate. Well, that's the thing that he sees. Well, that's what he sees. He sees the different accounts. He can add up new account. He can delete accounts. So let's log out and let's enter again. Okay. The last thing to do is to add up a captive portal to the interface where your outsourced employees will connect through. That's our interface. Security mode, captive portal, and restricted to the guest group. Okay, so now we have user group, we have created the user account, we have chosen the password, but the password can be auto-generated and sent to our user email. And now let's move over to our Ubuntu device, which is connected to our interface. And from here we have the captive portal. And there we have it. When you have different devices on the same interface, you can actually split them into groups and assign each group a different guaranteed bandwidth. You do it using a traffic shaping on the interface itself. Let's see how. To create a traffic shaping on an interface, you will need to create address objects for the different objects or devices on your interface that you wish to guarantee specific bandwidth. So in our case, let's look at finance, which is at the 10.0.7.0 subnet. Now, I've already created two address objects. Let's just look at them. Those are PC1 and PC2. One is at the 10.0.7.11 and the second is at the 10.0.7.22. My aim is to give PC1 10% of the bandwidth and PC2 90%. You can of course change it per your needs. So the very first thing that you will need to do is to create a traffic shaping policy. Let's create a new one. Now we'll create a traffic shaping for PC1. The source is PC1. Destination is all. Service is all. You can of course change it to each service that you wish to apply those limits. Now in the action you assign shaping class ID. The outgoing interface is our WAN interface, and in the traffic shaping class ID you can actually assign different class IDs. Just press the create. Now you have up to 31 class IDs. Let's choose class number 10. No, 10 is already taken. So let's choose class ID number 5. Let's name it 5 also. All right. So we'll assign it class ID of 5. Okay. Let's create another shaping policy for PC2. Source is PC2. Destination is all. Service all. Assigned shaping class ID. The outgoing interface is our WAN interface. And let's create another class ID number 6. Okay, now let's apply that. So we have two traffic shaping policies. Now let's move to traffic shaping profile. In shaping profile, we actually define the profile that we will enable on the interface later. So the profile is finest. Let's name it finest. And let's create new profile. Now the first class ID is 5. That belongs to PC1. The guaranteed bandwidth is 10% of the total bandwidth. The maximum is also 10%. Let's give them both priority of high. Okay. All right, so let's just choose class ID of 6, guaranteed bandwidth 90%, and priority high. Okay, now we have a new profile, which is the finance profile. We have two class IDs with different guaranteed and maximum bandwidth. You can also see the illustration here. Okay. The last thing that you will need to do is to move back to your network interface, finance. Let's edit this one. And on the traffic shaping, let's just enable outbound shaping profile. The shaping profile that we have just created is finance. Now you will need to specify your interface bandwidth. So in my case, it's 100 megabits. And there we have it. Did you know that your Fortigate has a built-in iPerf client you can use against public iPerf servers and test your bandwidth in a much more accurate way. In this following guide, we will look at how we do it, how we configure the different parameters such as the amount of TCP streams, protocol used, either UDP or TCP, coming up. Alright, so now let's use the iPerf client. Now, your Fortigate has an iPerf client, as said. It also has an embedded iPerf server. So let's start by checking throughput between two interfaces. To do so, you'll use the diag traffic test, client interface, and the first is our port 1, which is, no, let's use port 2, which is our marketing division. The second thing that we will do is diag traffic test, server interface, that will be our WAN interface. So let's use port 1. And if we'll use the diag traffic test show, we will also see the current configuration. Now to run the test, we will use diag traffic test run. And there we have it. Now, it's not that interesting to look at the bandwidth or the throughput between two interfaces. We want to check our Fortigate against a public iPerf server. Now, there are dozens of public free iPerf servers that you can find on the internet. Fortinet doesn't allow you to enter the URL. You will have to enter the IP address. Now, to start that, we will use diag traffic test. Let's use our client, which is at port 1. That's our WAN interface. Now, the next thing you can also do is to use different protocols. Now, if you use Proto 0, that is TCP. If you're using Protocol 1, that is UDP. So if you have voice over IP devices on your network, do the test over UDP also. But for now, we will use Proto 0, which is TCP. Another thing that you can do, if you use the diag traffic test run -h, you will see the different parameters that you can tweak, that you can play around. One of them is the -p. The -p actually allows you to send parallel connections, parallel streams to the server itself. It is much more accurate than one TCP connection. So use it, use 6, 10 streams towards that server. It will give you a much more accurate result. All right, now let's just move back. Now let's just use the diag traffic test. Let's run it. Let's run it against our server, which is a public server that is at 89.84.1.222. Now, we have forgotten to do one more thing, that is using the port number. The port that it uses is 5209. The default port for iPerf is 5201, but this one uses also 5209. So let's just use that port, and let's use diag traffic test run -c, and the address is 89.84.1.222. Your IPS engine is probably one of the most valuable resources of your Fortigate firewall. Now, it has different database signatures for data rate signatures, for anomalies, for exploits, and most of us just pick signatures of high priority and apply them to the policy itself. Now, there are several commands, command line commands, that you need to know to fine-tune your IPS and understand whenever there is an issue with the IPS, such as CPU spikes, or maybe your FortiGate gets into a conserve mode, you will need to analyze the issue. Optimizing your IPS engine coming up. If you're having issues with your IPS engine in terms of CPU spikes, CPU utilization, the very first thing that you will need to do is to use the direct test application IPS monitor. Now press the question mark and enter. You will see a list of options that you can choose from. The most important ones, in my opinion, is the option number 5, toggle bypass status. So let's just use number 5. When you do so, you actually enable bypass or disable bypass. That is, if you're still having an issue with your CPU after enabling the bypass, that is, your IPS will still work but it will not inspect traffic, then you're probably having an issue with a network congestion, or your FortiGate is not up to the task. There's too much traffic. But if you're disabling bypass, that is, your IPS still works and inspects traffic, and you're still having issues with the CPU, that means that you probably have an issue with your IPS engine. Now you can turn or disable your IPS. You can do it using option 2. And if you want to start your IPS engine again, you can use option 99. That will actually restart all your IPS engine's operations. So you can do that, and it actually restarts all your IPS operations. The second command to optimize your IPS operations is done in the global configuration of your IPS. So use the config IPS global. Now, if you press the show full configuration, you will see a list of options. You can choose the database, either regular or extended. You can choose the size of the buffer itself, the socket size. It depends on your FortiGate model. If you are using a FortiGate with several CPUs, you can actually even choose the number of IPS engine. But one of the most important options that you can play around is the intelligent mode. Currently, it is by default enabled. The intelligent mode actually means that your FortiGate IPS engine will look at the session itself. It will not scan by default every byte in this session. It will look and it will use heuristics and other techniques to choose if to scan the whole session or to stop scanning the traffic, the session traffic, upon recognizing that it is secure enough. So be sure that you're using the intelligent mode that will actually offload CPU resources, memory resources from your FortiGate. There are times when we need to customize our own IPS and application signatures. The quick guide to creating your own signatures is coming up. Don't go anywhere. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. When we speak of the intrusion prevention systems, we speak of an engine that compares traffic against signatures. Signatures of known threats and anomalies. Now, whenever the IPS engine alerts us, it's in our responsibility to either block, monitor, or allow the traffic. Signatures allows us to identify malicious attacks. And the question that arises is, why do we need to create our own customized signatures? Fortinet has already provided us with thousands of signatures. There are two main reasons. The first one, sometimes we use a specific application, we use our own set of tools or our own topology that is customized to our need, and we need to create a customized signatures that will match. And the second reason is for threats that somehow doesn't have any signatures yet. So how do we create one? Let's head over to our IPS sensor page, signatures view, and then create new. The following signature is probably the most basic one. If you want more advanced signatures, please leave a comment in the comments page. Our first signature will allow us to block the CNN.com website. There are dozens of ways using web filter application controls to do it, but we are here to learn how we customize our own signature, and that's a good start. Now, every signature starts with a header. The header for every signature starts with F, SBID, that's the header text, and then we open parentheses. In the parentheses, within them, we enter the signature matching criteria. Criteria of that signatures are described using a keyword and a value. And different keywords, if you're using a different keywords, you can use only one keyword and a value. You will divide different or separate different keywords using a semicolon. The first keyword is usually the name of the signature. We have to give our signature a clear description of the attack, and then we define the signature triggering. What makes it active in the attack? Which type of protocols are we looking into? The flow of packets, the amount of packet. We are looking for matches in the traffic itself. We match based on specific headers, specific patterns, thresholds, as in rate-based engines. For that, we use keywords. Two types of keyword example is service and protocol. Now, in service, we determine, as in our case, that the service is HTTP, since we wish to block a website. In protocols, we can specify if we will use TCP, as most websites use, or maybe we plan to block our site not only to users that go through TCP in their browser, but also users that may connect to that website using different protocols such as FTP. Each keyword must start with a pair of dashes. Another keyword is flow, that is the flow of the traffic. Does it come from the server towards a client, or from clients towards a server? Or maybe it is bidirectional. In our case, we wish to block any users that are clients from going to a web server that is the CNN.com web server. And there are many more parameters and patterns that we can add, but this is the basic syntax that we use to customize our signature. So let's try one right now. Let's name our IPS signature. Let's add some comments. So we will start with the F-S bid and we will open the parenthesis. Now let's choose a name for the custom signature and our name will be blockcnn.com. The next thing to do is to add a pattern. We will use a regular expression pattern that is cnn.com, and now our Fortigate will detect the URL, and as we add up the service, which is HTTP, it will know that it will only look up for that specific signature over HTTP protocol. Make note that we divide the different keywords with a semicolon. And now we will set up the protocol, which is actually the traffic type. Fortigate will only detect the signature in a TCP traffic. That is, if we will send a mail to that URL which runs over SMTP, or if we will connect to that URL over FTP, it will not do anything. It will only block the website over HTTP traffic. By default, patterns are case sensitive. So if we wish that Fortigate will block any attempt to get into that URL using uppercase or lowercase, we will use the --no_case. And now let's limit the scanning only to traffic that is sent from the client. We can also use bidirectional, but in our case we will use the --flow from client. And the last thing to do is to add up the --context host, which makes the domain name to appear in the host field as it being resolved by the DNS. So that was our basic signature. Now, if you wish that we will create a more detailed, a more complicated signatures, just leave a comment in the comments page and I will do so. In this video, we are going to show you the top 5 IPS commands for your Fortigate, and we are starting right now. The inclusion of IPS in your Fortigate is one of those things that makes your Fortigate a next generation firewall. It deals with exploits, it deals with anomalies. IPS engine is just about everywhere. So let's start with our first command, that is config IPS global. There are some Fortigate models that supports also the extended database, which includes much more signature. So to check it out, set database, and you can use the regular and you can also use the extended. So if you have the extended, don't hesitate to use it. When we create or configure IPS sensors, we need to plan them carefully. Why? Because they consume a lot of resources from your Fortigate in terms of CPU and memory. Now, whenever you head up to your IPS signatures page and add signatures, think of two main things. The first one, operating systems. If you're using a Windows-based network, don't use any signatures that are related to macOS or Linux. The second thing is the direction of the traffic. Now, if you're protecting clients, use only signatures that are meant to protect clients. If you're protecting server, do the same. The next command is for those who runs a Fortigate with multiple processors. You can actually run several IPS engines simultaneously. So how do you do it? You head over to your CLI, configure IPS global, Now set engine count. Now if you set the integer into 0, then Fortigate will choose how many engines to use simultaneously, but you can also change it according to your needs. Your IPS engine needs as much power as it can get. There are many Fortigate models that supports hardware acceleration, either using the NP ASIC or the CP ASIC. Mine uses the CP ASIC, so why not giving it to him? Use the config IPS global and then set, in my case it's the CP, set CP acceleration mode. Those that supports the NP, just use the set NP acceleration mode and set it to basic or to none, or in this CP case to an advanced mode which supports more IPS patterns. Your IPS engine consumes lots and lots of memory and CPU cycles. Now, if you see spikes in your Fortigate due to CPU high usage and so on, you can diagnose, test application, IPS monitor, and there you will see different tests that you can do on your IPS engine. You can disable it totally using option 2, or you can toggle bypass status, which actually means that the IPS engine works but doesn't scan any traffic. So play around with those options whenever you have issues with your IPS engine. And before we end, please subscribe to get more videos like that. Two features that you must enable on your IPsec tunnel to make it more secure and more reliable. Coming up. Your IPsec tunnel is actually comprised of two phases. Those are phase 1 and phase 2. In phase 1, IKE is the protocol that is being used and manages the connection itself, the tunnel itself. It is also responsible for the SA. Those are the security association, the cipher algorithms, and the hash functions that are actually being negotiated between the two peers. Now, in phase 1, which is the initial phase, you will see a forward error correction feature that you can enable or disable. Why do you need to enable it? Well, since that feature adds additional packets with redundant data. So if for any reason your connection suffers from congestion and you're seeing packet loss, forward error correction will help you to reconstruct any packet, any lost packet or error that you will see in the transmission. Now it will add up to the time that it takes to build up the tunnel itself, but your tunnel will be much more reliable for the long term. The second feature that will make your IPsec much more secure is the perfect forwarding secrecy. Now, you will see it only in phase 2. The thing is that in phase 2, your IPsec tunnel will actually extract new keying material from the Diffie-Hellman key exchange. Now, we will not get into the Diffie-Hellman algorithm and how that works. I will just say that it is being used to share or to create a shared secret key between the two parties, between the two VPN gateways. Now, if you're not enabling perfect forwarding secrecy, the Diffie-Hellman that is done at phase 2 will actually extract new keying material from the initial phase 1 Diffie-Hellman key exchange. If you enable perfect forwarding secrecy, there's a new key exchange that is being performed, the keys that are actually being generated are not dependent on the first phase. So this will make your process a bit more slower, but it will make your IPsec tunnel much more secure as you are using a new session keys that cannot be compromised nor derived from the initial phase. If you're using one of the latest firmwares on your Fortigate, then you have probably seen that on an interface you can configure receive LLDP and transmit LLDP. Now, what is an LLDP? An LLDP is actually a link layer discovery protocol used by most network devices to advertise their capabilities, their identity. Who are the neighbors? Who are they connected to? Now, we have seen link layer discovery protocol before. Cisco has one which is proprietary, that is the CDP. But now you can use LLDP to know which devices are connected to your FortiGate. So let's enable device identification and let's see how LLDP shows up in Wireshark. Coming up. A receiving LLDP device actually stores the data that it got from its neighbor on a database. Now, that database can be accessed using SNP. If we want to use LLDP, we have to turn on device identification and we have to turn on LLDP receive and transmit per interface or on a global basis. We will do it per interface. So let's move to the command line. Now we can also do it using the graphical user interface, but we will do it on the command line. All right, so let's just clear the screen. Config system interface. Now the interface we're dealing with is port 2. So let's edit port 2. All right, now let's set device identification to enable. Let's set LLDP reception to enable. And let's set LLDP transmission also to enable. Let's just get out of it and let's refresh our page. And there we have it. We have receive LLDP enabled and transmit LLDP enabled. And if we scroll down, we can see that we also have device detection. Now let's capture the traffic using Wireshark and let's see what happens. Let's open up Wireshark. Let's capture the traffic. If you'll do so using your home network devices, you will probably see that your smart TV uses LLDP to find out nearby devices. LLDP is used just about everywhere. Let's stop our capture and now let's filter LLDP. All right, let's just double click on the frame itself. Let's open up all the different headers so we can actually see that we're having the marketing. Remember, the marketing interface is the interface that is supporting either receiving and transmitting LLDP information. We can also see our device name, which is our Fortigate. It is a virtual machine. That's the build type. You can find tons of information on each device that is sending LLDP frames towards other devices on your network. On your internal LAN, you have 3 web servers that serves the same data. Now, when a client asks for that data using HTTP GET, you can actually load balance the request between the three web servers. How do you do it? You're using a load balancing virtual server. You can load balance the traffic based on different protocols, either HTTP or HTTPS, and you can use different load balancing algorithms such as weighted, round robin, or even one that has the least round trip time. So let's do it. Creating a load balancing virtual server is quite similar to creating a virtual IP, but this time we're creating a virtual server with different load balancing algorithm and from different types. So the first thing to do is to head over to System, Feature Visibility, Load Balance, and Apply. Once you do so, you will see that in Policy and Objects, you have a new Virtual Servers menu. Let's just create one. Let's name our new virtual server web server. The type will be HTTP, but you can also use HTTPS and other protocols. The interface is our WAN1. Now, although it is virtual, it has to have an IP that you got from your ISP. The virtual server IP, let's just make that one 82.0.2.1. Remember, an IP address that you got from your ISP. The virtual server port will be 8080. The load balancing method, now you can use different algorithms. If you want to treat the web servers equally, then just use round robin, but you can also use weighted. If you will use weighted, you will see that when you create a real server, you can actually add weight to the different servers, but we'll use round robin. Now, persistence, it's a good practice to use a cookie. If you're using e-commerce, do so. Let's just do so. And you can also actually create a health check. The same way as you create a health check monitor to check different servers for route failure, you can create a health check that will ping the different servers and get their round trip time and more parameters. But we are not using health check. Now, the next thing to do is to actually map the virtual server to our real server. So let's just create a new server. Now that's the IP address of our servers in our LAN interface. So let's just use the 10.0.4.1. Port will be port 80, and when you're using maximum connections equal to 0, that is limitless connections. The mode should be active. Okay, now let's create another web server that will be at the 10.0.4.7. Again, port 80, maximum connection 0, and active mode. All right, so we have two servers, two real servers, one virtual server that our clients will actually connect to from the outside, from the internet. And the next thing to do is to actually create a policy that will allow users to connect to our web servers. So we'll create new, let's name our policy. The policy name will be web server balance. Now the incoming interface is our WAN interface. The outgoing interface is our web server LAN interface. The source can be all. Now the destination, you need to move the inspection mode to proxy, and from there just choose destination as our web server. Now it won't work if you will do it using the flow-based inspection mode. Scheduling always, service all. Make sure that you are using net mode and dynamic IP pool. Now you can use any security profile over it, and that's about it. Up until now, in our different configurations, we have configured Google's DNS server as our main DNS server. We also configured DHCP services to run on just about any interface of our Fortigate. But if we need a local DNS server that will serve different hosts in our LAN and will be private only to the LAN users, we can do it using DNS databases. Coming up. So currently I'm using Google's DNS server as my primary DNS server, and as my secondary I'm using the FortiGuard DNS server. Now, if I want to create a local DNS server that will hold records of different hosts on my local area network, such as my web server or my NAS, I will need to head over to System, Feature Visibility, Enable DNS Database. Alright, and now in Network you will have a new menu which is DNS Server. Now we will start with the DNS database. We will create the zone itself. The type is master, since our DNS server will be the master DNS server. The view will be shadow. It will not be public to other users beside my LAN. So only users in my LAN can actually use and see the DNS server. Let's name the DNS zone. Let's just name it my company. And the domain name will be fortitip.com. The host name of our DNS server will be DNS. Let's just leave aside the email address. The other settings, the time to live is currently 24 hours. Let's leave it that way, and we will disable the authoritative, since we don't want our DNS server to be authoritative. We only want to be recursive. That is, in the case that it doesn't have the right answer or it doesn't have the answer, it will actually send it towards another DNS server. Now let's create the DNS entries. So let's create a record, which is actually the IP address behind a host. Let's name our host web server, and the IP address of our host, just for our demo purposes, is 10.0.3.88. Okay. Now, the other thing to do is to actually apply it to the interface itself. So let's just apply it to the interface, and let's make the mode to a recursive mode. Now we have configured only one A record to our web server, but you can add up as many as you wish. One of the things that has been removed from FortiOS is device-based policies. You cannot just block devices based on their operating system or type, as it was up until 6.2. So the next logical thing to do is to create a firewall address object based on the MAC address and use it in our policy. Coming up. You can create a firewall address object based on the MAC address using different methods. The first one is using the command line config firewall address. Let's do my MacBook. So let's edit Mac, and let's set the type to Mac. So that's one way to create a MAC address for specific devices. The second way is to use policies and objects, addresses, and now create new address, where you can actually create a MAC address object. The third thing, which is my favorite, is to head over to users and device. From here, device inventory, where you see the different devices on your interface, assuming that you have enabled device detection. Now head to your device, right click on it, create firewall address object, MAC address, and once you do so, just name it. Let's name it my MAC, apply, and now you have a device, a MAC address object device. Now move to your policy. Now create new policy. Let's name it block device, and let's use the incoming interface as my management interface, outgoing is my WAN, and the source is the new MAC address object, which you can block. Clients in your LAN are opening hundreds of sessions every day using different applications. Now, there are times when you need to limit the maximum concurrent sessions per IP address, that is per host. How do you do it? Using Traffic Shaper. Coming up. When we think of traffic shaping, we usually think of limiting bandwidth to a specific IP or to an entire local area network. But we can also limit the maximum concurrent sessions per IP in Traffic Shaper policy. So let's do it. Let's assume that we have our LAN that is at the 10.0.4.1 and we have our Ubuntu device which will be at the 10.0.4.9. So let's create a firewall address object for that specific IP address. Let's just name it Ubuntu, and let's make it at the 10.0.4.9/32, and interface will stay any. Okay, so we have our new Ubuntu address object, and now let's move to our traffic shapers. Create new shaper. Now we can create a shared shaper and we can create a pair IP shaper, and that's the one that we will use. Let's name it max concurrent, and let's limit the maximum concurrent connections to only 100. That is, it will not be able to create more than 100 sessions. All right, now once we configure the pair IP shaper, let's just configure the traffic shaping policy. All right, let's name it max concurrent. And now the source is our Ubuntu device. Destination, all. Service will also be all. Now we can apply that policy, that traffic shaping policy, only to specific application, which may become handy, but in our case, we will not limit it to a specific application. Now outgoing interface, let's just apply any, and let's use the pair IP shaper that we have configured before, maximum concurrent. Your Fortigate memory is limited. That's a fact. Even if you have a high-end Fortigate, you must understand how memory is being allocated between the kernel, the system I/O cache, the different buffers, the shared memory, and more. And how can you optimize your memory utilization for maximum performance? Coming up. This item is for every Fortigate administrator out there. Memory utilization and memory optimization is one of the key fundamentals that you should master. So memory actually is being distributed between the kernel, between the buffers, between the processes, between many operations that are on your FortiOS architecture. And let's take a look at one memory component, which is the slab or the slabs. Those are memory objects that are used by your kernel. So DAG, hardware, sysinfo, and slab. That is one, I believe, one command that you are not using frequently. And when you press enter, you will see all the memory objects that your kernel holds. Those could be TCP sessions, IP sessions, routes that are used in the cache. Now you can see on the left side the slab name, you can see the size of the slab, and you can see the amount of objects. So these are only one area where your FortiGate reserves memory. The second place is the DAG hardware sysinfo. Now we have two commands. We have the memory and the shared memory. Once you do so with the memory, you will see the total amount of memory, the free memory, the memory that is used by the buffer, the memory that is used by the cached operation. Now, this is important. Your system input and output uses cache. It uses cache very often for logging, for explicit proxy, for when optimization. Cache is used everywhere on your FortiGate. Now here you can see in the active cache, you can see processes or applications that are actually used often and some that are not used that often. Now, if we'll use the DAG hardware sysinfo shared memory, you will see memory that is being shared by processes. Now, processes have their own memory allocation. A process cannot just get into another process memory allocation. It lives on its own proprietary memory allocation. But there are different operations that your FortiGate actually allocates a specific shared memory for different processes to reach. And those can be seen using the DAG hardware sysinfo shared memory. Now, another command is the DAG systop, which we have actually used and handled a lot. This actually shows up the different processes that are used on your FortiGate and the memory allocation for each process. Now you will most likely see processes that consumes lots of memory, such as the IPS. You will also see processes as the HTTPS-D, the HTTPS daemon, which is actually the graphical user interface that we work on. What we actually see is child processes. So there is not only one process, there's the parent process, and there are child processes. All right, so now let's move on to memory optimization tips. Memory optimization can be done in many ways. We will look at a few. So the very first thing, don't just log anything on your firewall policies. There are cases when you need to log security events. There are cases when you need to log all sessions. Do that according to your needs. The second thing, security profiles. Don't just apply any security profiles out there. If you're using antivirus, don't just use any protocol out there. If you're using IPS is one of the most consuming, there it is, sorry, is one of the most consuming security profiles out there. Its engine actually parses, decodes the different protocol, looks for patterns, looks for anomalies. So use it carefully. If you're having a network that is comprised of only Windows machine or Windows servers, don't use signatures that are targeted at Linux OS or Mac OS. Use your IPS very carefully. Now, the next thing that you will need to know is about session time to live. Your session table by default holds sessions for up to an hour. That is not necessary in most of the cases. And here you can actually use the config system session time to live, and you will set the default. The default currently is 3600 seconds. You can set it to 600 seconds, and trust me, everything will be all right, unless you have applications, specific applications that needs a more longer session time to live. But in most cases, that is not the case. All right, now you can also configure that on a firewall specific policy or even on a specific service. So you can use the config firewall service custom. You can edit. Let's just name this service. Let's name it LS, just for the sake of the name. And here you can edit the port, sorry for that, set, not edit, TCP port range, and let's assume that our TCP is 443, and here you can actually set the session time to live to 600 also. All right, now the other place where you can play with the session time to live is actually when your Fortigate initiates a TCP session. Now, a TCP session has actually what is known as a three-way handshake. It starts with a SYN, it listens for the SYN ACK, and then it replies with the ACK. Now, between those stages, there is a time limit. Now, you can change that time limit. Let's see how. You do that using the config system global. Let's just get out of this one. Let's clear the page. Config system global. And here you can actually set the TCP half closed timer and the TCP half open timer. Now, the TCP half open timer is the time that your Fortigate actually waits to hear the SYN ACK. That is, it sent the SYN request, it waits for the SYN ACK. By default, it waits for 10 seconds, but you can change it. You can change it to 7 seconds. Will reserve more resources, that is memory resources, from your Fortigate. The same goes for the half closed timer. By default, it is 120 seconds. You can change it to 80. Now, all of these tweaks should and will make your Fortigate much more memory friendly. So you have decided to take the NSC 4 exam. Now, what do you do? How do you practice? What do you need to know? Well, in this coming video, we will look at the best tips to make you prepared. Coming up. The first tip is to be practical. Leave aside the dumps, leave aside the study guides. Head over to a Fortinet support site, download one of the VM images of the latest builds, open it in your browser of choice, and start playing around. Create new interfaces, configure the different services on that interface, create new policies. Even if you don't have any other machine to play around, think or dream of different use cases, such as anyone in your LAN is forbidden to use FTP traffic beside a specific device. How do you configure that policy? How do you create a firewall object of that device? So think around and play around with different use cases. The third thing, play around with security profiles. Configure new profiles, understand how they work, and apply them to your policies. Apply them to your policies and understand how they actually work, either in a flow-based or a proxy-based inspection mode. The theory behind those two is crucial to understanding how the security profiles work. The second tip is understand the terms. Head over to your command line, diagsys session list. Now, once you do so, you see in the output so many terms that may be frightening at the first time. What is proto number 6? What is state number 6? What does it mean origin shaper? What is the serial of that session? What is an NPU? Get around with the terms. Understand how sessions work on your FortiGate. Your FortiGate is a session-aware firewall. Understand the different numbering for different protocols. TCP protocol is protocol number 6. The UDP protocol is protocol number 17. ICMP is protocol number 1. Each have different states. Understand the numbering, and you will see more terms such as fail open or made dirty. Many terms that you need to walk over in the Fortinet documentation, understand them, since you will probably, in the exam itself, you will probably see outputs with the following terms. Understanding the basic actually means that you need to know how different components on your FortiGate actually work. If you play around with an antivirus, you have different databases. Let's just clear the screen. Configure antivirus settings. Now, you can set the different databases using the command line. Are those databases being downloaded locally to your FortiGate, or are you using any cloud repository? The same goes for web filter. If you're creating a new profile, you have the FortiGuard category-based filter. Is that a database that is being downloaded, or is it a cloud repository? Another example is the routing table. If you look at the routing table using the CLI with the get router info routing table all, does it have precedence over the policy route? Or maybe the policy route have precedence over the regular routing table. So these are the basics. Understand them, as you will probably have some questions related to those topics. In your exam, you will probably face some network troubleshooting questions. So look very closely at the topology that is shown. Look at the different IP addresses, look at the subnets, look at the classes. Try to understand if that topology makes sense. You will probably face also some outputs, such as the diag debug flow or the diag sniffer packet. Analyze what is the reason. It may be a networking issue, it may be a policy issue, it may be that you just don't have any static route to the destination. So look around closely and understand the topology before answering. We tend to forget, but your FortiGate can actually work in a transparent mode and act as a switch, a device with only one broadcast domain, its management IP. So you can set the op mode, the operation mode, either to NAT, that is a layer 3 device, or to a transparent, which is a layer 2 device. You will be asked questions regarding to VLANs. You will be asked questions regarding to virtual wire pair. You will be asked questions regarding your Fortigate as a appliance that sits between two segments of the network. It doesn't do any routing, but it only scans the traffic that passes through. So know your way when your Fortigate works in a transparent mode as a layer 2 device only. Your Fortigate is part of a security fabric with multiple components that are on the network itself. You will not have to answer questions regarding Forti Analyzer or Forti Manager. Those are different components and have their own certification. But you will need to understand how load balancing works. What is an SD-WAN, is software defined WAN, how to prioritize traffic based on load balancing algorithms or based on different SLAs, service level agreements that you create. You will also need to know what is an HA. An HA, high availability, is the way that you actually create a redundant Fortigate along with your primary Fortigate. You can create it either in an active mode or active passive mode. Understand the priority of creating a master Fortigate and a slave Fortigate. Understand how sessions are distributed between those components. Remember that your Fortigate is a network device, and as such it will have its load balancing and redundancy algorithms in place, which you need to excel in. One of the main rules or main jobs that your Fortigate does is to authenticate users while entering the network. Now, you will need to understand how a user is created, how to connect to a remote authentication server such as LDAP or Radius. What is a single sign-on? How do you create a proxy? What is an explicit proxy and what is a transparent proxy? How do you transfer your proxy settings using a pack file? What is an authentication rule? Understand the aim of authentication. Understand what does it take to authenticate different users using passive authentication or active authentication. Those will be probably asked throughout the exam. Be sure to understand the whole nature of authentication fully. You've been asking for that, and here it is, an OSPF tutorial. Open shortest path first, a dynamic protocol which is used extensively all over, and your Fortigate supports it. So let's start. The idea of OSPF is quite complicated to understand if you're dealing only with static routing and you're not dealing with large networks. Now, let's try to simplify things. Think of a large network. Now, divide that network into different areas. In each area, you have what is known as internal router or an OSPF router. Now, each router actually supports a link state protocol. That is, they have a full view of the topology. That topology is actually kept, or that tree that is actually kept within OSPF LSDB. That is a database that each router holds, and sends that database between each other and to what is known as an ABR. An ABR is an area border router. That router actually has lag or has an interface that is connected to that specific area, but it also has an interface to another area. Now, each LSDB is sent from the internal routers is sent to our ABR. Our ABR is connected to other areas. There are actually two types of area. There's the plain area and there's the backbone area. Now, each area has to be connected to the backbone area. The backbone area has an ID, which is always 0000, and other areas can have IDs up to 32-bit range. Information that is actually retrieved within that area is sent between different ABR or ASBR. An ASBR is similar to an ABR, but it is also connected to a non-OSPF routing protocols such as RIP or any other dynamic protocol. All right, so to recap, we divide an OSPF area into several areas. Each area has an ID in the 32-bit range. Each internal router in the area sends what is known as an LSDB through a message which is known as an LSA. There are different types of messages. We will not get into it. Those messages are sent between the routers and are sent to the ABR, which holds one LSDB database that has the full view of the topology of the network itself. Now, LSAs are sent each 30 minutes. It can be configured. Between different ABRs, we send what is known as an LSA type tree, which is actually a summarize of the network, and that is only done with the ABR itself. Now, when we configure OSPF on our Fortigate, we actually configure usually our WAN interface to broadcast the OSPF, the LSDB information to other ABRs or ASBRs. Now, we will do so using the command line, and we will see the results using the graphical user interface. All right, so let's start. All right, so let's start with the OSPF configuration. So we have a WAN interface. We will use that interface to distribute our LSDB, and we have connected subnets. We have the finance subnets and we have the office subnet. Our WAN interface is at the 10.0.3.56. Now, if you move to OSPF, by the way, it is not by default enabled, so you will have to use, if you haven't used it before, system feature visibility and enable dynamic routing protocols. In OSPF, you will have to set up the router ID and you will have to set up the area ID. Now, these two can be in the range of a 32-bit number, and you will also have to actually create the interface or the network that you wish to distribute along with the interface. We will start by doing so on the command line, and everything will be much more clear. So, config router OSPF. Now let's actually set the router ID. And this will be 75. Let's now config the area, and let's just do it. We will not use, you know what? Let's use the backbone area. Let's assume that it is in the backbone area. All right. Next. And the second thing is to actually configure the network, the WAN interface that has all the connected subnets. The connected subnet will be also distributed. So let's edit one, and sorry for that, config network, there it is, edit one. Now we're actually setting the network, the WAN interface, which is at the 10.0.3.56. We also need to actually set the net mask, which is 255.255.255.0, and let's set the area again, which is the backbone area, and let's just end it. All right, so now let's just refresh our page. And once we refreshed our page, we can see that we have actually created a router ID. We have created the area, which is the backbone area. Remember, 0000 is the backbone area. We have also configured the network that will be actually distributing through the LSAs. And we need to configure the, let's just name it port 1, that's our interface, and you can set up a cost that is between 0 to 65,000. The lowest is the better one, but we will not use cost for now. Now the hello interval is usually 30 seconds, so set it up to 30 seconds, and the dead interval can be 180 seconds. All right, now let's just apply that. Now once we apply that, you will see that you also have advanced options. We will not get into the advanced options, but you can see that all connected subnets will also be redistributed through that message. So let's just distribute the static routes that we have. We don't have any RIP or BGP routes, so we will only redistribute our static routes. All right, now let's just move to our routing table and look for the OSPF that is already being configured on our WAN interface. So for that, we'll use the get router info routing table, just that, routing table database, and we can see that we have OSPF configured on our WAN interface. Now we want to see our database, we want to see our LSDB. So for that, let's just use the get router info OSPF database brief. And here we can see that we are actually at the 75 area, and here we can actually see the links in the network itself, which is at the 10.050, 10.060, and 10.070, all being distributed using the WAN interface 10.030. Whenever a ping, an ICMP request is being sent from one of your Fortigate interfaces or sources, the defaults are 5 times, that is, the packet is being sent 5 times. It has a data size of 56 bytes. It is being sent in a 1-second interval, and you have a 2-second timeout. Let's see how we can unleash your ping settings. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. Using ping, an ICMP request, is probably one of the most used yet simple network troubleshooting tools. So let's unleash our ping setting and see what can be done. We will start with the execute ping, and then we will use the view settings so we can see what is our ping default settings. So we can see that we have a repeat count of 5 times. We have a data size of 56 bytes. We have a timeout of 2 seconds. Currently, the interface is auto, which means that it actually goes to our routing table and sees the best route out. We have an interval of 1 second. That is, your ping will be sent 1 second after the echo response received. You can use an adaptive settings, which we will do very soon, to see that you can actually send the second or the third ICMP request immediately as the ping response comes back. The time to live is 64 hops. Let's see if we have any more interesting stuff here. No. The second thing that we can do is to set the ping options and see what are the ping options. And we can see that we can set an adaptive ping, we can set different data size, we can set DF bit, which is a parameter at the IP header. We will look at it. We can set the interface that the ping will be sent from. We will use our marketing interface and send ping from there. We can set the hex format of the ping. We actually can add different characters to our empty hex space in our ping. We will look at it also. And yes, we can set the source, the timeout, time to leave, and more. So let's start with a simple ping towards Google. Okay, that's google.com. That works. Now we'll use the same ping towards Google DNS server and see if we have a DNS resolve. That also works. Great. Now let's close that for a minute. Let's move to my Ubuntu device. All right. All right. Now my Ubuntu device sits on the it sits on the marketing interface. Let's just get back. Let's log in. All right. All right. So let's start by pinging my Ubuntu device, which is at the 10.0.4.9. Everything goes well. You can see that I have a very big ICMP packet. Let's see what is the reason. Execute ping options. You know what? Let's do another thing. Once you have settings that are not your default settings, remember the default settings is 56 bytes. You can reset them using the execute ping options and reset. Now let's send the same ping again and let's see what is the size. That's 64 bytes. Remember that your data size, your ICMP data size is 56 bytes. You have an 8-byte header for the ICMP packet. What you see here is actually the payload itself plus the header. That is 56 plus the 8-byte header. Let's see again how we change the data size. That's the way that we change the data size. Let's set it to 128 bytes. And let's now change another settings, which is the adaptive ping. Your ICMP request is being sent in an interval of 1 second. Now you can change it so that it will be sent immediately as soon as the ICMP response gets back. To do so, you have to choose enable. Another setup is the DF bit. What is the DF bit? DF stands for don't fragment. That is, don't fragment the packet even if it's bigger than the interface that is supposed to accept it. So if you have on the other side an interface with an MTU of X values and your ICMP packet is bigger than that, so your ICMP packet can actually be dropped. So be careful how you use the DF bit. Let's keep it at no. Now let's see what is the effect of adaptive ping versus the regular settings. So let's just execute ping. Let's use a repeat count of 20 packets and let's execute our ping towards Google. Sorry. Google.com. Alright, so you can see that we have an interval of 1 second. Now if we will use the adaptive ping option, let's just enable it. Let's send the same ping and you can see that you're actually having a sort of an ICMP flood. It's not hundreds of packets a second, but it is still much faster than the usual interval. When your Fortigate inspects traffic using different ports, different protocols, it has several options that you can enable or disable according to your needs. Let's look at the most used configurations for protocol options. Firewall protocol options can be accessed through the graphical user interface in Policy and Objects Protocol Options, where you can create new profile to your protocols of choice, but it is limited with features, so we will use the CLI. So here we'll use the config firewall profile protocol options. Let's just, sorry for that, there it is. Now let's just name a new profile, edit HTTP, and from here we can actually edit different protocols. The first one is HTTP, FTP, and so on. Let's use HTTP. And if you use the show full config, you will see the different options. Now let's pay attention to some of them. The first one is the ports. You can change the port number. The second thing to look for is the oversize limit. That is the in-memory buffer. Currently it is 10 megabytes. That's the default, but you can change it. It actually depends on your Fortigate RAM. Remember that usually malwares and viruses are less than 10 megabytes, so don't pay too much attention for the oversize limit. The second thing to look for is the uncompressed oversize. That is in the case that the file that is being sent as part of your traffic is actually being compressed. So your Fortigate will check in the header for the compression algorithm. If it has a password, then you have an issue, but if it doesn't have a password, then your Fortigate will actually decompress it. The next option is the uncompressed nest limit. That is in the case where the files are being compressed and then they are being again compressed and compressed. Your Fortigate will support up to 12 compressions, but again you can change it. It all depends on your Fortigate RAM. Another thing to look for is the streaming content bypass. Currently it is enabled, but you can change it to disable. The last option that is important is the comfort interval and the comfort amount. When your FortiGate inspects in proxy mode, the connection may actually time out. That is due to the scanning time that it takes. So your FortiGate will actually send packets to your clients and keep the connection alive. Now you can control the interval of packets and you can control the data size. So you've got your new Fortigate and you need to set it up. So here's a quick setup guide. Your new Fortigate comes with a pre-configured port 1 at the 192.168.199 IP address. So you can actually manage your Fortigate using the command line or using the graphical user interface. We will do it using the graphical user interface with a web-based manager. So take up your client, that is your PC or your Mac, change the subnet to something in the 192.168.1 subnet. It could be 1.10, 1.11. Connect your client to your port 1 on your FortiGate and just open up your web browser at the 192.168.199 address. When you will do so, let's just move on and see what happens. Alright, so you get into your browser, you type the address, the port 1 IP address, and you enter your administrator credentials. Now, if you have an older model, you would just use admin as a username with no password. On the latest firmwares, you will need to enter a password. I've already entered one, so let's just get into our FortiGate. And from here, let's just move to system settings. The very first thing you need to do is to change your host name. Now, it may sound not important, but if you have several FortiGates, one of them is protecting your data center and one of them is blocking users on another department, you will need to know which FortiGate did what. So let's just name our FortiGate marketing, so we will know that it protects our marketing division. The second thing to do, system time. The best practice is to use FortiGuard NTP so every appliance will be synchronized. Now you can set up different administrator settings such as the HTTP port, which you will probably keep at port 80, and HTTPS, which is 443. The other thing that you can do is customization. You can change your language either to English, French, Spanish, and so on. And you can also change the theme of your FortiGate, and you will see the different theme change immediately. Now, let me just use this one since it looks much more modern in my opinion. We will not get into the NGFW mode, either profile based or policy based. That will have to wait for another video. Let's just move on. Email service, you can use the custom settings, which are FortiGuard's SMTP email server, or you can use your own or whichever SMTP server that you will use, and you will see that you will use your email SMTP server more and more as you practice your FortiGate. The other thing that you can do is to head over to FortiGuard, and in FortiGuard and in antivirus and IPS updates, enable the accept push updates so you will not miss any signature that is being pushed by the FortiGuard servers. The other thing that you can do, server location, use lowest latency locations. It is a good practice to do so if you're not in the US. Alright, so those are the default settings. Now if you move to administrator, remember you're the administrator of your Fortigate. You can edit your administrator profile, add up your email, add up two-factor authentication, and you can also add up what is known as a trusted host. That is, only administrators that connect to the Fortigate management interface through one of those IP addresses that you will configure will be permitted to enter. So you can set up your trusted host to your IP address at work and your IP address at your home location. You can also set up new administrator, and you can actually add up a professional administrator that will take care of different areas on your Fortigate. Once you configure your settings and your administrator profile, you can add up more interfaces, ones that are connected to your WAN interface and to your other LANs. I have a bunch of videos that will show you how to do so. And the other thing that you will need to do is to create a static route, a default route that will connect the traffic, the packets that needs to get out to the interface, to your gateway. That is the interface that is connected to your WAN interface. All right, so this was a quick setup guide. From there, you will probably move to policies and object, create your own policies, customize your interface, customize your settings, your logs and reports, create security profiles, and so on. Authenticating users through a remote server such as a radio server or LDAP server is fundamental on any firewall. Now I'm using Jump Cloud Radios as a server, and I have already created user groups. Let's just take a look at the user groups and some users that are on that user group. We will configure the radio server on our Fortigate. We will configure the user group to be authenticated on our policy, and we will look at how it all happens on our Ubuntu device. So let's start. So we have a fairly simple topology. We have our LAN interface, we have our WAN interface. The very first thing you need to do is to head over to users and device, and here we will configure our radio server. So just create a new radio server. My radio server, as you just saw, is called home server. Now you need to enter the IP address of that server. That's the IP address of Jump Cloud servers in Europe. Now the shared secret key is between our Fortigate and the radio server. This is something that you configure on your radio server. So let's just write it down and let's test connectivity. All right, so it's successful. We initiated and configured the radio server. Now you can move to config user radios. Sorry for that. User radios. Let's just add it home server, and let's use the show full config. Here we get the information of our server. We haven't created the bind to the user group. We will do it very soon. But one thing that you should note is that if you're using another radio server that is not using port 1812 as most radio servers use, you can actually set the radio port to something else. 0 by default is 1812. All right. Now let's create the user group, create new user group. Let's name our user group admins, It's the same group that we have on our remote server. Let's add it from home server and let's apply. Now, the third thing, apply that to your policy. Let's add up our user group, admins. Okay. So we finished our Fortigate configuration. That's a very basic radius configuration. And now let's move to our Ubuntu device. Let's open up Firefox. Now, you see that there's a prompt that says that you must log into the network before you can access the network itself. So let's open up the network login. You can see that your Fortigate actually listens at port 1000. TCP port 1000 is used by your Fortigate to listen to interfaces that has policy with authentication on them. All right, so let's just, I'm a user, that's my username, that's the password. Let's continue, and here we have it. When you use Deep SSL inspection with your Fortigate, you can actually generate a new unique certificate. Deep SSL inspection is used when your Fortigate actually impersonates as the recipient of the original SSL traffic. Now, it is a good practice to use Deep SSL, and it is sometimes, at least for older models, a good practice to regenerate a unique certificate for each Fortigate. So how do you do it? Coming up. All right, so let's take a look at the current certificate. Let's use the config VPN certificate local, and let's edit the Fortinet CA SSL certificate and type the get command, and here we can see the certificate itself. We can see that the issuer is Fortinet, and we can see its validity, and we can even see the hash value. All right, so let's just get out of here, and let's now regenerate a unique certificate for our Fortigate. We'll do so by using the execute command, VPN certificate local generate default SSL certificate. Now, when you press enter, you will be asked if you want to regenerate the default CA certificate. We'll use the yes, and we actually generated a new unique certificate for our Fortigate. Now let's just get back to the first command, which was the config VPN certificate local. Let's edit the Fortinet CA SSL certificate, use the same get command, and we can see that we have a different certificate with a different hash value. Here it starts with 5F, and here it starts with C6. Regular expression is one of those powerful tools that you will need to master, either if you work as a Fortigate administrator, a checkpoint administrator, or just playing around with your Linux or Mac terminal. So here is a quick tutorial on how to find IP addresses on a configuration file from your Fortigate firewall. Coming up. For a quick tutorial, we will use our Fortigate configuration file. So let's move to admin configuration, backup, and let's back up our configuration into our local PC. Now let's open the configuration file. Let's just copy everything in it. And I will use the Reg 101 website, which is a great place to learn regular expression and paste the configuration into the text pane. All right, so we have hundreds of lines. Some of them includes IP addresses, some of them not, and we will try to look for IP addresses, only IP addresses. All right, so let me write down the pattern and then I will show you the logic behind it. And as we can see, we have 36 matches. That is, we have found 36 IP addresses. To understand the logic behind it, let's just delete what is in the text pane and let's write down something that includes IP addresses. I have connected through 10.0.3.44 and the connection to my WAN interface at 111.100 was great. All right, so let's look at the pattern and understand what we are actually doing. So the very first thing that we can see is that we are using either square brackets, which is also known as a character class. We are using curly brackets, which are known as quantifiers, and we're using a backslash and the dot characters. Now, the square brackets actually defines the characters inside, and if we separate characters or digits in our case with a hyphen, so we actually define a range of characters or digits that our regular expression will look for. The second thing is the curly brackets. So here we define a quantifier. That is, it looks for a repetition, it looks for a match between 1, 2, 3 times. So we can use it to look for repetition in digits 1 up to 3 and more times. Now the following is a backslash and the dot characters. We need our pattern to follow a dot after each pattern. So to do so, we use the dot character, but the dot character in regular expression actually means anything. So we have to escape it. How do we escape it and make sure that our regular expression looks for the dot character? We use a backslash. Now the last quantifier, as we can see, is the number 3. If we change it to number 2, you will see that it will not look for 4 consecutive matches. It will only look for 3. If we change it to 1, it will only look for 1 consecutive match. So we have to use 3 consecutive matches to be sure that we have a full IP address. As a full IP address is built of 4 octets. That is a pattern of 4 consecutive numbers. Each number, as we have just described, is made up of 3 characters. Application control is probably one of the most used security profiles in your Fortigate. And in this era of COVID-19, I thought of bringing up a video that will show up how we can block remote control apps such as TeamViewer and how we can override it. So let's start. Remote apps is all over. So let's move to my Ubuntu device and let's just open up TeamViewer and see that everything goes well. There it is. And it's ready to connect. So it has a green light and everything is okay. So now let's just quit TeamViewer. Let's get back to my application control, create new application control. Let's just name it block TeamViewer. And let's move to the remote access category and block it. Okay. Let's move to my policy, the policy between my Ubuntu device and the WAN interface. And let's enable in application control, let's enable the block TeamViewer. All right, so now we have created a security profile. We have enabled it in our policy. And let's get back to our Ubuntu device. And let's open up again TeamViewer. And let's see what happens. It probably still has some cache in it. Let's just full quit of TeamViewer, and let's just open it again. And we can see that it is not ready. It has issues with connectivity. So let's quit this time. Let's quit here and let's go back to our policy. Let's just disable the block TeamViewer security profile. Let's move back to my Ubuntu device and let's open up TeamViewer again. And again, it's ready to connect. That's great. Now, let's assume that we want TeamViewer to work, but we don't want other applications, other remote apps to work. So only TeamViewer will be overridden from the security profile itself. So let's move back to my Fortigate. And now let's head to our application, security application control, block TeamViewer. Now we will keep the remote access blocked. And here in application override, let's look for TeamViewer. There we have it. Let's just add all selected. All right, and the action, let's just edit the action. Currently it is blocked, but let's allow it. All right, apply. So again, we have the same security profile, but currently it will stop any remote apps out there but TeamViewer. So let's get back to our Ubuntu device. Let's just quit TeamViewer and open it again. All right. And there it is. So it's ready to connect. There are no issues, and it's the only remote app that is allowed to work on our environment. Your Fortigate supports two main VPN technologies. The first one is SSL VPN, where you can use the web-based portal or the full tunnel. And the second technology is IPsec. Now, let's assume that you have a remote worker that wishes to connect to the marketing LAN using a remote IPsec, and doing so using its Android tablet. Let's look at the configuration steps coming up. Alright, so the basic topology is quite simple. We have a web interface where our users will connect through to our marketing LAN. So the very first thing to do is to create a user and a user group. So let's create a user, create new, local user. Let's just name it test and assign a password. Next, a user group. Let's create a new user group. Let's name our user group VPN users. And that's quite okay. And there it is. That's the user group. All right. So we have a user group. In our user group, we currently have only one user, which is the test user. All right. So the next thing to do, the next logical thing to do is to create the IPsec tunnel. Now we can use a custom configuration. This time we will use the predefined templates. One thing that I want you to take a look is that we currently only have one policy. We currently only have one policy, which is the marketing out policy. That is, everyone who is in the marketing LAN can get out to the internet. We will see that once we finish to configure our remote IPsec, we will have more policies that are already created for us. So let's move to our IPsec wizard. Let's name our IPsec remote, and let's use the remote access. Now we are using an Android tablet, so we'll use the native device type and Android native. Next, the incoming interface is our WAN interface. We will use a pre-shared key, so our pre-shared key will be configured here, and here we need to assign the user group, which is our VPN users. The local interface is actually the interface that we wish the remote users to connect to, and the range. Now, users that will connect to our remote IPsec will be assigned a new IP address. So we need to create a range for that IP address. So let's just create the 192.168.1.2 up to 192.168.1.11. All right. And let's assign here the local address. All right. Now, that's it. Now, once you finish that, you will see that you already have the phase 1 and phase 2 already being configured with the encryption algorithm and the hash function and the Diffie-Hellman groups, but we also have a new L2TP policy that is already created. So we can actually move to our policy and objects, and here we can see that we have two new remote policies that were created. We can also see in the interfaces that now currently under our WAN interface we have a new tunnel interface. So let's move to my Android tablet. I'm using a mirror application. Let's move to settings, VPN, and let's choose VPN and let's create a new VPN profile. All right, so the name of the profile of the VPN network will be marketing. The type is L2TP, which is using a pre-shared key. The address of my WAN interface is 10.0.3.59. And now we need to enter our pre-shared key. And here we will enter the user that is allowed, the one that we have just configured in the VPN users group. All right, so let's connect. and we're connected. So you have started to learn how to administrate your Fortigate, and you're playing with virtual machine images of the Fortigate machine. Now, after the 2 weeks evaluation license, you will get the license expired message on your dashboard. How do you renew your free license without getting back to the Fortinet support site? Well, with this simple trick. The following trick to renew your free evaluation license has nothing to do with changing the date or the time of your virtual machine. It is much simpler than that. All you need to do is to head over to your VM machine, resume your machine, log in to your machine, and the next thing to do is to execute the factory reset. Once you do so, you will be asked to approve the operation. And once you approve it, just config new interface on your virtual machine, an interface that is in the subnet that your computer is in. And from there, head over again to your FortiGate device on that specific IP address that you have just configured, and you will get another 2 weeks of evaluation license. Now, if you have some old configuration on the old machine, just back them up, head over to admin backup, and on your new machine, restore the old configuration. This is one of the CLI tips and tricks that I wasn't aware of. You can actually save your configuration just by logging out. Coming up. Alright, so currently my configuration is quite simple. I have 3 interfaces, I have only one policy, and let's just back up the configuration again, and let's look at the revisions. Currently I have only one revision, which is my first backup. So let's make a change. Let's just add up another policy. Let's name the policy Ubuntu, and the incoming interface is the, let's make it the LAN interface. The outgoing will be my WAN interface. Source, let's make it all, and destination, let's make the destination only to gmail.com, just for the sake. There it is. And service will be all. Alright, so I have a second policy, and now instead of backing up my configuration, I will move to the command line, config system global. Now let's set the revision backup on logout. Let's set it to enable. Let's end it, and now let's log out. All right, and let's just log in again, and let's look at the revision. And there I have it, automatic backup that were triggered by the logout. Now let's look at the first backup, and let's select the second backup. And by right-clicking on the 2 backups and choosing diff, which is the difference, I will actually see the difference that were made between the first backup and the second backup. And there it is. That's the second policy that were added. All right, so now let's make another change. Let's just add up another interface. let's just let's add up another interface. Let's name the interface management. All right, that's at the 10.0.8.1/24. We will use HTTPS and ping and enable the DHCP server. All right, now let's just log out again. Let's move to the revision, and there we have it. We have a third automatic backup that was triggered by the logout itself. Now we can see details, we can see different items, and let's look at the config itself, and there it is. That's the port 4 that we have just configured at the 10.0.8.1. Your Fortigate is a session-aware firewall. When it receives a packet from a client towards any destination, it looks in the routing table, it does a route lookup, and saves the routing information in the session table. When it receives the second packet, the one that came from the destination towards the client, it saves the route lookup, it does another route lookup, it saves it into the session table. Now, your Fortigate actually relies on 3 routing databases to forward the packets. The first one is the policy-based route. The second one is the routing cache. And the third one is the FIB, the forwarding information base. So let's take a look and see what is in each database. When you check your routing table using the get router info routing table all, you see the connected routes, you see the static routes, you see dynamic routes such as OSPF or RIP, and you see just about any active that is best routes that there are on your Fortigate. If you use the same command with the database, you see every route that there is in the routing table, including routes that are not active. Now, one thing that you're not seeing on the routing table is the policy-based route. If you move to network policy routes, you can actually create routes that are much more granular in terms of the protocol that is being used, the source address that is being used, and so on. Now, those routes can only be seen using the diag firewall proute list. Here we can see that I actually have 2 routes. One is towards Gmail and the second one is towards Microsoft Office 365. The policy-based routes are actually the first place that your Fortigate checks to see if there's a route towards the destination that is in the policy-based routes. If it doesn't find a match, the second place that it goes to is the routing cache. The routing cache is actually a mechanism that deals with performance. You want to route as fast as possible, and your Fortigate actually has a dedicated memory to cache entries such as routing cache. How can you see the routing cache? Using that command, diag IP RT-cache, and again list. Here you can see all the latest routes that are saved on the cache itself. It doesn't save all the routes that are in the routing table, only the last entries that are frequently used. Now, the third place that your Fortigate checks, if it doesn't actually find anything in the routing cache or in the policy-based route, is the fib. The fib, the forwarding information base, holds the active routes, not every route, but only the active routes. It gets them from the routing table. It also holds routes that are dedicated to SSL VPN or IPsec. How do you get to see the fib? Well, you use the get router info kernel. And that's the fib. That's the third database that your Fortigate checks before it sends the packet towards its destination. A key routing concept on your Fortigate is RPF, reverse path forwarding. It is a mechanism that protects you from IP spoofing, and it works like that. Any packet that is sent towards your network is checked. If there's a route towards the source IP, the packet will continue to its destination. If there is no route to the source IP, the packet will be dropped. So if 10.0.1.3 wants to connect 192.168.2.8, it will do it successfully. We will soon look at the routing table and understand why. But if 172.16.7.8 tries to connect 10.0.1.3, then the packet will drop. The reason is as following. If we look at the routing table, then everything becomes much more clear. So in our Fortigate routing table, we can see that port 3 has a default route. It is quad 0. So our client can get out and reach its destination since we have a route to the source IP. Now the other client, the 172.16, goes out through port 1. In port 1, if we look at the routing table, we have a static route to a network or to a destination at the 8254. That is not our destination. And we have another connected network, which is the 192.168.1.0. So port 1 doesn't have a route back to our 172.16 and the packet is dropped. Now there are two types of RPF. There's the strict RPF and there's the loose RPF. The loose RPF tells us that there needs to be a route to the source IP. The strict RPF tells us that we need to have the best route to the source IP. It can be configured on your firewall. Let's see how. Alright, so that was a long opening, but it is important to understand how RPF actually works. So to configure RPF either in a strict mode or a loose mode, you actually use, you know what, let's just look at our routing table, router info, let's use the database. Alright, so that's our routing table. We have an OSPF route, we have connected networks, and we have a static route, which is the default route. Now the loose RPF is the default. So let's just use the config system settings and set source check, strict source check. Now if we enable the strict source check, then we actually enable the strict RPF. Now if we enable strict mode, then it will look for the best route, the active route in the routing table. If we disable, which is the default, then we stay with the loose RPF. In most use cases, use loose RPF. The following is a very typical scenario. You have a host, which is part of your local area network, and you want to track its sessions, the places that your host connects to. Now, you can do it in multiple ways. You can look at login report, you can look at the FortiView, but let's do it using the CLI coming up. So here is the following scenario. You have a Ubuntu device which is part of the 10.0.4.0 subnet. Its IP address is the 10.0.4.8 and we want to track its sessions. Now, as I said, we can do it using FortiView, we can do it using log and report, but let's try to do it using the command line. So the first command that you can use is the get sys session list. And from here you can see all the different hosts in your networks and their different sessions. Now, if you want to be more granular, you can just use the grep command. And let's just grab the 10.0.4.8, and here we can see that our host is talking through UDP towards the 888 Google's DNS server. Now, the other way to do it is using the sys session list. Now let's move over. And as you can see, we have dozens of sessions that are happening just now. So we have to use filter. So what we will do is to use the sys session filter. Now our filter will be the source address, which is the 10.0.4.8. And now what you'll do is to use the sys session list again. And there we have it. We have specific session that is related to the 10.0.4.8. Now you can use the grep command again to filter and be more granular on the different items that you seek, such as the type of protocol. Now it's using protocol 17, which is UDP, which is the protocol that is used to connect to Google's DNS servers. The following is a very typical scenario. You have a host, which is part of your local area network, and you want to track its sessions, the places that your host connects to. Now, you can do it in multiple ways. You can look at log and report, you can look at the FortiView, but let's do it using the CLI coming up. So here is the following scenario. You have a Ubuntu device, which is part of the 10.0.4.0 subnet. Its IP address is the 10.0.4.8, and we want to track its sessions. Now, as I said, we can do it using FortiView, we can do it using log and report, but let's try to do it using the command line. So the first command that you can use is the get sys session list. And from here you can see all the different hosts in your networks and their different sessions. Now, if you want to be more granular, you can just use the grep command. And let's just grab the 10.0.4.8. And here we can see that our host is talking through UDP towards the 888 Google's DNS server. Now, the other way to do it is using the sys session list. Now let's move over. And as you can see, we have dozens of sessions that are happening just now. So we have to use filter. So what we will do is to use the sys session filter. Now our filter will be the source address, which is the 10.0.4.8. And now what you'll do is to use the sys session list again. And there we have it. We have specific session that is related to the 10.0.4.8. 8. Now you can use the grep command again to filter and be more granular on the different items that you seek, such as the type of protocol. Now it's using protocol 17, which is Udemy, which is the protocol that is used to connect to Google's DNS servers. This video is all about setup tips for your Fortigate, and we are starting right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the most common questions that I get every time is, how do I set up my Fortigate? I'm not interested currently in any intrusion prevention system sensors. I'm not interested in IPsec VPNs. I just have several interfaces connected to different LANs and I need to set up my Fortigate for truly a basic operation. So in this video, we will look at the basic setup configuration. As you know, in my channel, you have tons of videos that deals with different aspects of your Fortigate. So the very first thing is to set up your administrator profile. You're probably the super admin of your Fortigate, so make sure that you connect through trusted host. If you need to set up a new admin, maybe a professional admin that will be responsible for another virtual domain or different aspects of your Fortigate, do it. So the next thing to do is to move over to network interfaces. You probably have different LANs connected to different interfaces in your Fortigate. In each interface, don't forget to write down an alias. It will help identifying which LAN belongs to which interface. Use specific roles for specific interfaces. Use administrative protocols carefully. Don't just let anyone ping from that interface if it is not needed. Use DHCP server and use DHCP server scopes so you can create different DHCP options for that local area network. You can block specific MAC addresses from receiving IP addresses. And use device detection and active scanning. You want to know which devices initiate traffic on that interface. Now the next thing to do is to create or configure a static route that will lead to your ISP. Now it is usually created using the default route, which actually means that any packet that is destined to anywhere and it does not have any entry in the routing table should head up towards the specific gateway, which is usually the WAN gateway. The next thing to do is policy and objects. That is the bread and butter of your Fortigate firewall. It is where you create rules that match any traffic that comes in or gets out of your Fortigate. Assuming that it matches the traffic, you have two decisions. The first one is to accept, the second one is to deny. Now you can create different policies according to different topologies. The basic policy is the full access policy, which allows local area network to get out to the internet through the WAN interface. So incoming interface can be just about any LAN in your network. The outgoing is the WAN interface. Source can be different users' devices, but let's assume that we deal with just about anyone. Destination also can be specific destination, but let's assume that any destination is allowed. You can set up different scheduling and services. Now, again, you can deny specific protocols, but for our case, we will allow any service. Now, the learn policy is another topic that I have made a video specifically on that, but that's not the issue right now. Now, whenever Fortigate matches the traffic, the next decisions are we going to log the traffic? Are we going to net the traffic? Net is also very, I would say, not difficult, but it is a tough topic to understand. And then it implies the security profiles, which can be antivirus, web filtering, IPS, and so on. And our last setup is actually moving into the log and report and see whatever happens in your FortiGate. Now, there's a lot of happening whenever traffic comes in and gets out, whenever an admin logs in into one of the interfaces, whenever there's a VPN tunnel that initiates or stops working. You need to maximize your understanding on what is happening on your network. And the best thing to do is to look at the login report and understand your network baseline. SNMP protocol is the protocol that helps you to manage and monitor your device health. That is, memory is too low, CPU is too high, and so on. In an SNMP world, there are three key components. There's the database of objects, which is also known as the MIB. There's the SNMP agent. That's the device that you're monitoring. That device can also send what is known as SNMP traps. Those are events that are happening and being sent to the SNMP manager, which can also query the device whenever it wishes. Now, there are different versions of SNMP. The latest is version 3, which is much more secure. It adds up authentication and encryption. So let's look at it. All right, so to configure SNMP, you'll move to System, SNMP, and the very first thing that you will see is the databases, the MIB databases. There are two. The first one is a database that is unique to Fortigate firewalls. The second one is a MIB that is quite global. It is for every Fortinet device out there. So here you will find objects that are unique to Fortigate. Here you will find objects that are global in the sense that they will fit to every Fortinet device. Now, the thing that we want to do is to configure an SNMP agent. So let's just enable it. Let's describe the SNMP agent. That's a Fortigate office. All right. Location, office. That's just for content info. Let's use our admin, which is admin@gmail.com. Okay, now when we configure, we can configure either SNMP 1 and 2 or SNMP 3. We will configure SNMP 3, but if you create a new configuration on SNMP 2, you will see that you have what is known as a community. A community actually aggregates the devices, but it is not secure. It is only plain text name that anyone actually can use and can take a look at your SNMP agent at the different objects or different events. So we will actually use the SNMP version 3, which is a user-based security model. That's quite different. So let's add up the name. Let's just name it offer for our demonstration. And the security level can be either no authentication, authentication only, and authentication and privacy. So we will use authentication and privacy. In authentication, we will choose the hash function that will be used to hash our password. Let's use SHA-256. Don't choose MD5. MD5 is way old and not secure anymore, so SHA-256 will be quite okay. You can change, of course, the password. Let's just write down a password. And the second thing is the encryption itself. We need to encrypt the data that is moving between the SNMP agent and the SNMP manager. For that, we will use AES encryption. I'm not sure why Fortinet actually even allows someone to encrypt in DES. DES is way old and not secure anymore. So choose AES 256. That's a much more secure encryption algorithm. And here we also need to choose a password. That's a password. That's another password. That's not the same password as you are using for the authentication side. That's another password that is used for the encryption. All right, now here you will actually enter the IP address of the SNMP manager. So let's just add up an address. And here we actually permit our SNMP manager to send queries. Now, the port is 161. If you have other port that you need to change it here. The traps are actually the events that your agent sends towards the SNMP manager, and you can choose the different events. So again, those are the different ports. Those are the default ports that are being used by SNMP either for queries or for traps. And those are the events that you can actually choose to send traps. So CPU usage is high, available memory is low, log space is low. You can even send an event whenever a new device comes up and shows up in the network itself, or if the IPS package is updated. Okay. And that's about it. Now you will need to add up the credentials, as in the host name, the authentication password, the password that is being used for the encryption, and of course the two MIB files to the SNMP manager. Your connection starts with a DNS request, a DNS response, and there comes the TCP three-way handshake, and when it's done, you send an HTTP GET request. The basic denial of service attack works on the TCP three-way handshake. That starts when the client sends a TCP SYN, the server sends a TCP SYN ACK, and then again the client sends an ACK, a TCP packet with the ACK flag on. Now on a denial of service, a hacker sends a TCP SYN, the server sends back a TCP SYN ACK, and the hacker doesn't send back the TCP ACK. That connection is known as half-open connection. Now, it has limitations in terms of time. It has limitations in terms of buffering, the server's buffer. But when that happens, quite fast, our server will not accept any more connections. So what do you do and how do you protect your servers from SYN flood attack? Half-open connections are happening all the time. It can happen due to congestion in the network, due to bad connectivity. It even happens due to different applications that behave so. But you can limit the timers, the time that your server will wait for a TCP SYN ACK. So let's just see how we do it. We go to our CLI, config system global. And now you can set the TCP half closed timer and half open timer. The half closed timer actually tells our FortiGate you can terminate sessions that are waiting for TCP packets with the fin flag that is set to on. Now the half open timer is what we have just saw. Our FortiGate actually waits for the TCP ACK that is coming from the client and is actually the last step in the three-way handshake. So you can set different timers that is according to your network behavior. Another thing you can do is actually go to the policy and objects, IPv4 denial of service policy. Just choose your interface. It will probably be the WAN interface. And there you can set the rate of the TCP SYN float. That is, set the maximum SYN packets rate for 1 second. Currently, the threshold is 2000. You can set it to 1000 packets. You can set it to 500 packets. You can set it to more. It all depends on your network behavior, on your server's behavior. You know it better than anyone. 2 minutes CLI, and this time how to configure your interface using the command line. Coming up. This is probably one of the most used commands, that is my most used command. Now, config system interface actually configures the physical interfaces or the virtual interfaces on your FortiGate. You can do it either on the graphical user interface, and you can do it also on the command line, and that is exactly what we will do right now. So let's just use the config system interface. The second thing to do is to pick up the interface, the port number that you wish to configure. Currently my VM has only 10 ports, so let's use port 3. Now from here you can set the different parameters of your interface. So we will start with the mode. Will it get its IP address from the DHCP server? Or maybe we will set it statically. So let's use static. Now, once we use static, we can set the IP itself. So let's use the 10.0.5.6 and /24 since we are using a class 3 IP address. Now, the other thing that you will need to set up is the allow access. That is the protocols that you will use to administrate your interface. So we will use HTTP and HTTPS. You can also use ping, which is not a best practice unless you need it for different purposes. But the most used is HTTPS and SSH. SSH to enter your interface through the command line, HTTPS to enter it through the graphical user interface. The next thing you can do is you can set the MAC address of that interface. You can actually configure yourself the MAC address for that interface. You can also use the MTU override. Currently the MTU is 1500 bytes, which is the standard, so don't change it unless you really need to, but if so, you can set the MTU override. Now you can also use set wait from 0 to 255. Wait is used in different scenarios such as load balancing and preferring one route over the other. You can also use the, you can also set your interface to a specific VDOM, and currently our VDOM is the root VDOM. Let's just end it and let's refresh the page, and there we have it, port 3 with the new configuration. One of the techniques to block applications like TikTok is to get hold of IPs that are related to TikTok or list of domains that are related to TikTok and block them on your DNS filter. How do you do it? Coming up. TikTok has gained a lot of attention recently due to the fact that it probably gets hold of your private and sensitive data. Now, I'm not taking any position on either if it does so or not, but if you want to block, then one of the techniques that you can try and block any domains or IPs that are related to TikTok is the following. You start with a text file where you enter all IPs that are related to TikTok. Just Google TikTok IPs, domains, how to block, and you will find a list of IPs that are related to TikTok. Once you do so, save your text file, uh, put it in a web server in a place that is accessible, and move over back to your Fortigate. On your Fortigate dashboard, fabric connectors, create new connector of type thread fits IP address. Now name your connector. Let's just name mine TikTok and enter the address of that text file. So I will just use an address that doesn't really exist, but for our purposes. If you need to authenticate it, then you can enter your credentials on the following fields. If not, just disable it. Okay. Now, once you have a new thread feed with a list of IPs that are related to TikTok, move over to your security profile, DNS filter, create new DNS filter. Let's just name mine DNS block. External IP block list, and add up the external thread feeds. Okay, now move over to your policy and objects, and on your policy just enable the TikTok block security profile. Now this is not bulletproof, and IPs are changing frequently, but this is one method that may be of help when you need to block TikTok connection with clients that are connected to your network and are monitored by your Fortigate firewall. Welcome to our Fortigate top 5 tips, and this time we are dealing with the ping command. Tip number 1. When we use the ping command, we use the execute command. So we'll use the execute ping and we'll choose our destination as 8888, which is Google's DNS server. Now we can see that our ping size is 56 bytes and Fortigate sends 5 packets at a time. Now we can change the size of our ping. How do we do it? We use the execute ping options. Let's view the settings. All right, and now if we will use the execute ping options, data size, we can choose ICMP packets to be in different size. Let's choose 90. So now our ping size is 90 bytes. Let's choose the same target. Execute ping towards 8888. And you can see that our ping size is 90 bytes. And to our second tip. Now, if you do networking for a long time, you probably send continuous ping packets towards different destination, different interface. So you have to change the amount of packets to be continuous or to be at a different size than the 5 packets that are sent by default. How do we do it? We use the execute ping options and we use a different repeat count. Currently the repeat count is 5. Now let's change it to 15. And now let's ping again. And let's ping the Google DNS server. And let's see how many packets are being sent. And we can see that we have 15 packets that are sent. And now for our third tip, let's clear that out. Now, we have different interfaces in our Fortigate, and sometimes we wish to send ping packets from different interfaces. So how do we do it? I have currently an interface at the 10.0.4.1. So let's use the same execute ping options. And now let's choose a different source. In my case, it's the 10.0.4.1. And now if I'll use the same ping command, the packets will be sent from the 10.0.4.1. Moving on to tip number 4. Usually a ping command is being discarded after 64 hops. Now we can choose a different integer. We can choose an integer between 1 and 255 hops. How do we do it? We use the same, sorry for that, we use the same execute ping options, time to live, and let's choose 220 hops, 220 hops. And now our ping packet will be discarded only after 220 hops. Alright, and now let's move over to our 5th tip. Sometimes as an administrator, you use different settings. Let's change the settings of our ping command. Let's use a repeat count of 8. Let's use a different data size. Let's make our ping size 80 bytes. And let's use a different source. Alright, let's use the 10.0.4.1 as our source. Now, if we will use the view settings, we will see that our repeat count is 8, our data size is 80, and our source address is the 10.0.4.1. Now, you want to reset those settings. What do? You use the reset command. And now if we'll take a look at the view settings, we will see that it all came back to the default settings, which are 5 packets, 56 bytes, and the source is according to the interface that you work within. Now, if you like our channel, please subscribe. When you start to diagnose processes that are happening on your Fortigate, you can use 2 commands. The first one is diagsystop. Let's just start it. Alright, let's stop it. And there's the diagsystop summary. What is the difference between the two? Which one is better? And how can you sort processes by CPU or memory? Coming up. Before we begin, let's just try to understand what is a process. Well, you have your app, it sits on the hard drive, on the storage itself, and when it loads into a memory, it actually uses different processes to accomplish its task. Now, a process is key to understanding what is happening on your computer, what is happening on your Fortigate in our case. Now, each process consumes CPU. It consumes CPU and it consumes memory resources. Every operating system has what is known as a user process and a system process. A user process is when a user actually initiates an app or a service, and the system process are actually processes that are done in the background. Now let's look at the diag system. The diag system will actually list processes individually. It would list all processes. It will show up the process ID, the memory that is being consumed, the CPU. The diag system summary actually aggregates all the processes. As you can see here to the right of each process, you can actually see the amount of processes that the operating system actually divided the process itself to several processes, and that is the case where your operating system makes multiple copies of a process in order to subdivide the load itself or to handle similar tasks. Alright, so now let's try to sort our processes in a descending order and see who is consuming more memory. So let's just stop it. Let's use the diag system summary. Alright, let's show only 5 lines. Use the sort command equals mem, that is memory, and now we can actually see processes in a descending order that only shows the most consuming processes in terms of memory. Now here you can see that this is the process that is currently running. Here you can actually see how many processes, that is user processes and system processes, are actually running. And here you can see to the right the amount of sub-processes, that is the same process, but this could be the parent process and the child processes that are running, that are actually running. So here we can see that we actually have 11 HTTPS processes that are running. All right, so to compare and recap, the diag system summary is different since it aggregates just about every child process and parent process into one process and shows you the total CPU and memory consumption. The diag system actually shows each process, so it is better to examine the memory utilization or the CPU utilization, but the diag system summary is better in my opinion if you need to adjust specific processes, specific applications, if you see that there is one process that is actually consuming your memory or your CPU utilization. DNS filter is probably one of my favorite security profiles. There are so many things you can do with that. One of them is the DNS translation. Your DNS server will actually take a resolved IP address and replace it with another IP address. So in the case where a user tries to navigate to CNN.com or any other website, your DNS server will actually replace CNN.com with another IP address that you have chosen. So let's look at how we configure DNS translation. All right, before we enable our DNS filter, our translate DNS filter, let's just ping one of the website that we wish to translate the resolved IP address. Let's ping ynet.coil. All right, let's just stop that and let's copy the IP address. All right, now let's move back to our DNS filter. Let's create a new DNS filter. Let's name it translate, and let's just enable the DNS translation and create a new DNS translation. Now the original destination is Ynet, that's the IP address, and we'll actually replace it with Google's DNS servers. Now let's add up the subnet mask. Okay, and let's just apply that to our policy. That's the full access policy. We're using a Ubuntu device, and we'll actually ping one more time and we will see the results. Now let's apply the DNS filter. All right. Now let's move back to our Ubuntu device, and there it is. Now let's just ping Ynet again. And there it is. You can see that once we have pinged Ynet without our DNS translate filter, it actually pinged Ynet's IP address. When we used our DNS translate filter, it actually pinged Google's DNS server. So the resolved IP, as used also in our ping command, has been translated to another IP address. If you've decided to use a proxy on your network, then you have two choices. The first one is explicit proxy, which we covered here before. And the second option is transparent proxy. Using transparent proxy, you don't have to configure a pack file. You don't have to enter the address of the proxy itself manually. The setup is much more simple. So let's configure a transparent proxy. When you set up a transparent proxy, the user will first hit the IPv4 policy, the basic IPv4 policy, and then it will be redirected to the proxy policy. So the setup is quite simple. We have a marketing interface at port 2. Let's just look at the policy itself. Policy is basic full access policy. The first thing that you will need to do is to set the inspection mode to proxy based and the SSL inspection to deep inspection. All right. The second thing, now the policy is labeled ID1, so let's set HTTP redirect. So let's open up the command line, config firewall. By the way, the only place that you can do so is using the CLI. The only place that you can redirect HTTP traffic is using the CLI when using a proxy. So config firewall policy, let's edit number 1, which is our policy, and let's set the HTTP policy redirect to enable. All right, now let's end it. The second thing that you need to do is to open up your proxy policy and configure a new policy, a transparent policy this time. The incoming interface is our marketing interface, the outgoing is our WAN, source is all, destination is all, service use web proxy. All right, here you can also use deep inspection. Okay. Now we're using a Ubuntu device, so let's just take a look that everything still goes well after our configuration is done. So let's just move to fox.com. Yes, everything goes well. Now let's move back to our Fortigate. All right, so let's move again to our command line. Let's use the diag-wed session list, and let's open that up so we can see better. And we can see that we have transparent proxy session. Let's look at the total amount. We have 4 transparent proxy sessions happening right now. If you're using a Fortigate with 2 hard disks or a virtual machine with 2 virtual disks, then you can use one of them for logging and the second one for WAN optimization. How do you do it? Coming up. All right, so let's look at get system status. Let's just look at the current disk that is being used, and it is being used for logging. Now we can set it to be used for WAN optimization. That is if you have two hard disks. If you have a virtual machine, you can add up a hard disk, and if you're using a Fortigate with two hard disks, one can be used for logging and the second one can be used for WAN optimization. So let's just look at the current disk usage, and we are actually using two hard disks. The first one is referenced 16 with 30 gigabyte, and the second one is referenced 32 with 3 gigabyte. Let's use the config system storage to look at the different virtual disk that are being used, and we can see that we are actually using this one for logging. We're not seeing the second one. If we will try to let's just do it, let's edit virtual disk. If we will try to change the usage for anything else beside logging, we are not permitted. We can only use it for logging. So to use the second hard disk for WAN optimization, we need to format it. So the reference number is 32. Let's just use execute disk format, and the number is 32. Now if we'll do so, we will need to reboot our Fortigate. So let's just do that. And we can actually see that we're actually formatting the disk, and it will probably have several partitions. Now it's being booted up. All right, so let's get in and let's get back to our Fortigate. And let's use our Fortigate again, config system storage, and let's just edit. We have virtual disk and we have virtual disk 2. So let's look at virtual disk 2, and let's look at the current configuration, and the usage is WAN optimization. So let's again use the config system storage, and let's look at the two hard disks, and we can see that the first one, the main one, is used for logging. The second one, our virtual disk 2, is used for WAN optimization. Recently, I'm asking users and administrators which security profile are you using the most, and everyone is answering web filter. I've made a poll on my YouTube page which security profile is most often used in your environment, and the same goes here. Web filter seems to be the most used security profile on a FortiGate firewall. Now, we will look at how web filter works. We will look at the different diagnose commands that you can use with your web filter. But this video is dedicated to only one tip, which is the web filter cache that you can actually and should extend its time to live. So let's start. All right, so this is probably one of the best tips that you need to use when using web filter. Your Fortigate actually checks or connects to FortiGuard servers to check the rating of the different web categories. There are dozens of categories. Now, each time it does so, it saves the results in a cache. Now, this cache has a session time to live. If you want to make your Fortigate performance better, you will need to make that cache stay for a longer time. How do you do so? Using the command line. So let's use the config system FortiGuard. All right, and now let's set the web filter cache. First, we will make it enabled if it is for any reason not enabled, and then we will set the cache time to live to 8,000 seconds. All right, now I believe that the default is 3600, so we are actually doubling the time, more than doubling the time, and making it stay for the cache for much longer. All right, so let's just check how many categories are there. Let's just look at web filter categories. Once you press enter, you will get the different categories and their numbering value. Now, you can use that number to learn more of the different categories if you head over to that URL. So that is a very specific URL. And once you enter the number of the category before the .html, let's look at category number 1. Category number 1 is drug abuse. You will actually get into a test page that describes the different categories. All right, so we saw how we extended the web filter cache. We also saw how we can get the numbering value of each category, so that we have dozens of categories. And the last command is the get system FortiGuard. And when doing so, we can see that our web filter cache time to live actually extended to 8,000 seconds. You can configure your Fortigate to become a secure web gateway using a proxy. Now, you can use either explicit proxy or transparent proxy. When using explicit proxy, you will need to add up the IP address of the proxy itself, either manually in the browser or using a pack file. When using a transparent proxy, nothing needs to be done. Now, we will use an explicit proxy on our Ubuntu device, so let's start. Configuring explicit proxy involves some steps, so we will walk those steps one by one. The very first thing, if you haven't enabled explicit proxy before, just move to System, Feature Visibility, and make sure that the explicit proxy is on. It is enabled. Apply. The second thing to do, on the interface that you wish to apply the explicit proxy, just edit that interface, and at the end you will also find explicit web proxy that should also be enabled. Okay, the third thing, explicit proxy, again, network explicit proxy. Here you can see that it is enabled on our LAN interface. The HTTP port is 8080, and here we actually enable the proxy auto configuration. Let's just edit the configuration file. We can see that if we have a host that is at the 10.0.5.7, that's our Ubuntu host, that's our mask, direct him to the proxy at the 10.0.5.1 8080. Apply that. Now, the proxy pack file have its own URL. You can use your command line, get web proxy explicit, and here you will find the syntax, which is HTTP, the address of that interface, the port, proxy.pec. So we need to enter that at the proxy configuration in our browser, either Firefox or Chrome. All right. Now that we have actually configured our explicit web proxy, let's move to policy and let's create a proxy policy. We already have one here. Let's edit our proxy policy. We can see that we have explicit web proxy policy enabled on port 2. The outgoing interface is our WAN interface. Let's not limit it to specific sources. We will enable it to all users without any credentials whatsoever. So the source will be all, destination all, schedule always. Service is web proxy. All right, now here you can apply security profiles. We can apply application control, antivirus, any security profile, the same as you would do on any other policy. So we have our policy, we have our explicit proxy pack configuration customized to our client, and the next thing to do is to move to our Ubuntu device. All right, so here, let's just open up our Ubuntu device and let's move to preferences, proxy, and we can set the proxy manually, which is at the 10.0.5.1. We can also set it using the automatic proxy configuration URL. And now let's just move to, you know what, let's open up Wireshark, let's capture the traffic, and let's just move to YouTube again, and why not? And here we can see that we have connections, we have sessions coming out from the 10.5.7, which is our Ubuntu device, towards 10.0.5.1, port 8080, which is our proxy port. Zones are extremely useful. They're simple yet powerful. The idea is that you take different interfaces and aggregate them into one zone. By doing so, every security policy that you apply on the zone will take effect on all interfaces. And by all interfaces, I mean physical interfaces and virtual interfaces, such as VLANs. Now, let's take the following. Let's create 3 interfaces, 1 zone, 1 policy, and 3 address objects. Coming up. All right, so the setup is the following. We have the finance division at port 3, we have logistics at port 5, and we have a marketing division at port 2. The marketing division also has a VLAN inside, which is the marketing managers. Now, we will aggregate all 3 interfaces into one zone. We will name that zone priority. And in sources, we will create 3 address objects. You can use those address objects for specific devices on your different interfaces. And we will also apply what is known as a block intrazone traffic, so that devices from different interfaces cannot communicate with each other. All right, so the very first thing is that we will actually, in network interfaces, create new zone. Let's name our zone. Let's name, you know what, let's do it using the command line. Let's do it using the command line. So let's open up the command line. All right, config system zone. Let's just name our zone. Let's name it priority. All right, and here we actually set either the intrazone. Let's just use deny so no one can actually talk to each other. And we have 3 interfaces. We have port 3, we have port 5, and we have a VLAN. And now let's set the interfaces. So we have, no, that's the intrazone, sorry for that. Let's set the interfaces. So we have port 3, and we have port 5, and we have the marketing VLAN. All right, let's end it, and let's now just refresh the page. And there we have it. We have the zone at the bottom of the page. The zone name is priority, and it includes 2 physical interfaces and 1 virtual interface. All right, now let's just create a policy. Let's move to our policy page. Let's name our policy the same as we named our zone. Let's name it interface. And the incoming interface is actually the priority zone. The outgoing is our WAN interface. We can also include internal local area network as our outgoing interface. In sources, now let's just create three sources that will belong to each interface. So for the first one, PC1, let's just create it belongs to our priority zone. Okay, let's add up another interface, another address, sorry for that. It's PC2. Let's just use 9.33/32. That also includes, it's also a part of our priority zone. And the third object, the third address object will be PC3. Remember, those devices, each device actually belongs to another interface. All right, so let's just let's add this one, and let's add this one and this one. So these are the sources. Each device belongs to a different interface, which is aggregated into our priority zone. In destination, let's just give them all. Service, all. And let's just enable application control and antivirus. In today's video, we will look at how to list processes, in your Fortigate using the diag sys coming up. A process that consumes too much CPU or too much memory, as the IPS process, can cause your Fortigate to have bad performance. So how do you tackle it, and how do you see the processes that are running on your machine? To do so, you'll go to the CLI, diag sys top. Now, following that basic command, which will display the processes, we can filter it using other parameters. So if we'll use 3, we'll have a refresh time of 3 seconds. Now if we'll use the 10 after it, we'll have 10 lines that are displayed. Now the last thing is the iteration. So let's use 3 for that, and let's see what we have. So we have 10 processes, again another 10 processes, and another 10 processes. Now let's look at the processes themselves and understand what do we see here. We actually see the process name, the process ID, the process state, either in sleep or running or maybe a zombie process. We also see the amount of CPU that your process is consuming, that is the row before the last row, and the amount of memory that it consumes. Your Fortigate CLI is probably your best friend when you're administrating your Fortigate. So, a new series dedicated to CLI tips. Let's start. The first CLI that we will look into today is the get system status. Now, it isn't a fancy command. It doesn't sniff any packets. It doesn't show the different sessions that are running on your Fortigate. It just shows you the information. What is your Fortigate up to? So what can we see? We can see the Fortigate version, we can see the build number, we can see the different security profiles, database dates. We can also see the serial number of your Fortigate. We can see if your